In a past so remote that it defies imagination itself, before time even had a name, space was a silent ocean, filled with stardust and echoes of ancient explosions. It was in this formless abyss that the sun was born, a young, restless star, surrounded by an immense cloud of gas and dust that spun around itself like an incandescent spiral. This protoplanetary disk, formed from fragments of dead stars and primitive molecules, would become the cosmic womb from which everything we know would emerge: the Earth, the seas, the mountains, living beings, and one day, ourselves. Within that luminous whirlpool, invisible forces began to act, transforming chaos into order and dust into worlds. The birth of the sun was an event of both violence and creation. Gravity, tireless and eternal, slowly gathered cold clouds of hydrogen and helium until the collapse became inevitable. The core heated up, and in an instant, shorter than a blink, nuclear fusion began. The star ignited. A sphere of fire was born, radiating energy in all directions. Around it, the disk of debris began to warm, spinning in spiral orbits. Within these incandescent belts, particles of dust collided, joined and grew, forming small, solid bodies. They were the embryos of planets, seeds of rock, iron, and ice, molded by the heat and the ceaseless motion of space. The region where Earth began to form was a violent territory. The temperature was so high that metals melted and rocks evaporated. Thousands of fragments called planetesimals collided constantly, creating waves of heat and energy capable of fusing matter. These collisions were destructive, but also creative. With every impact, the mass of a body increased, becoming denser, hotter, and more strongly pulled by gravity. The embryo of Earth began to form in this chaos, an incandescent sphere of molten rock surrounded by a whirlwind of debris. Meanwhile, the young sun unleashed furious solar winds, clearing nearby space and expelling excess gas. The solar system was taking shape, and the primordial hell of Earth was being born. But what we now call a planet was then just a scar in space. The internal heat was so intense that no solid surface existed. Everything boiled. The energy released by collisions and by the decay of radioactive elements kept the rock in a liquid state, creating oceans of magma. The sky did not exist, only toxic vapors and dust. With each new impact, the planet trembled as if breathing. Gigantic meteors fell at constant intervals, feeding the fire and melting again what tried to solidify. It was an endless cycle of destruction and rebirth, a heart of fire pulsing in the dark. Gravity, however, fulfilled its silent duty. Slowly, the heaviest materials sank to the center, forming a metallic core. Molten iron and nickel descended like glowing rivers into the interior, generating the magnetic field that one day would protect life. On the surface, the lighter elements remained, giving rise to the crust and, much later, the atmosphere. Earth was beginning to differentiate, to organize itself into layers, to become something stable within the impossible. It was a slow but inevitable process. Energy, heat, and gravity were creating balance, a structure capable of resisting and evolving. There was still no life, no oceans, no mountains. But the first step had been taken. Chaos was becoming home. Meanwhile, out there, the solar system was also taking shape. Jupiter, the gas giant, grew voraciously, devouring what it found along the way. Saturn was forming its rings of dust. Mars and Venus were being sculpted under the same fire that shaped Earth. Each planet followed its destiny, defined by distance, mass, and time. And amid that colossal dance, the small, still non-existent blue point began to write the first line of a story that would last billions of years. The sun shone more intensely than ever, and its heat sustained the birth of worlds. The disk of dust would eventually disappear, carried away by the solar wind, but it would leave behind a legacy: asteroids, comets, and frozen fragments that would serve as messengers between worlds. Many of these visitors would collide with Earth, bringing essential elements: carbon, nitrogen, phosphorus, the ingredients of future life. The universe was preparing the stage, and even without consciousness, without purpose, without soul, that burning chaos was slowly becoming the cradle of creation. From fire, water would be born. From destruction, life would arise. The newborn planet was not a home, but an open wound in the cosmos. The Earth, still young and unstable, burned like a living flame under the relentless gaze of the primordial sun. The surface was a vast ocean of molten rock, a landscape in constant transformation, where mountains of magma rose and disappeared within hours. No air surrounded the planet. No drop of water touched the ground. The sky was only a dense haze of dust and toxic gases, illuminated by flashes of red and orange light, reflections of a hell stretching from horizon to horizon. It was the time when fire ruled over all things, and Earth itself was the very definition of chaos. The heat was unimaginable. Temperatures above 1,500 degrees Celsius turned the ground into an incandescent sea. Rocks evaporated, metals melted, and the atmosphere, if it could be called that, was made of vapors of iron, sulfur, silicon, and carbon dioxide. The air was thick, suffocating, and corrosive. The entire planet twisted in geological convulsions. The crust had not yet solidified, and the seas of magma moved in slow, deep, and silent waves, like a heart beating in fire. It was a cosmic organism in formation, breathing lava and exhaling ashes. The bombardment of asteroids was constant. Rocks the size of mountains fell upon the planet, piercing the burning atmosphere and releasing enough energy to vaporize entire oceans, if oceans had existed. Each impact reignited the inferno, spreading molten fragments thousands of kilometers away. It was a cycle of destruction that prevented any attempt at cooling. The Earth tried to calm itself, but the cosmos would not let it sleep. And with each new collision, its body gained mass, its gravity increased, and its structure became more cohesive. Violence created stability. Destruction shaped solidity. Chaos, paradoxically, was the architect of order. Inside the planet, something extraordinary was happening. While magma boiled on the surface, the inner layers began to organize themselves. The densest materials, such as iron and nickel, slowly sank toward the center, forming the metallic core. The energy released by that movement generated enough heat to keep the planet boiling. The lighter elements, such as silicon, aluminum, and oxygen, rose and accumulated on top, creating the first solid rocks. This internal differentiation marked the beginning of the structure that would support all future geological evolution. The Earth was learning to be a planet, defining its physical identity like a seed germinating amid flames. Without a true atmosphere, the heat radiated freely into space, but not for long. Incessant volcanic eruptions released gases that accumulated above the surface, slowly forming a gaseous mantle. It was a dense and lethal air, composed of water vapor, carbon dioxide, carbon monoxide, ammonia, and methane. This suffocating mixture would become the embryo of the first terrestrial atmosphere. No living being could breathe that air, but it had a vital role: to retain heat and protect the planet from solar winds. Beneath that toxic dome, life was still billions of years away, but the stage was being prepared for it. High above, the young sun shone with relentless intensity. Its light pierced the haze and reflected off molten surfaces, creating a spectacle of metallic brilliance. There was no blue in the sky. There were no clouds, no shadows, no night as we know it. The rapid rotation of the planet produced short and violent days, and each dawn brought new storms of fire and dust. The Earth revolved around the sun like an incandescent demon, throwing heat, vapors, and light into the void. Yet something silent and mysterious was taking place. Within the chaos, within the fury, within the fire, harmony began to emerge. The universe was fulfilling an invisible plan. Over the course of millions of years, the intensity of cosmic bombardment began to fade. Large impacts became rarer, and the planet could finally start to cool down. Small portions of the crust solidified, floating over the sea of magma like fleeting islands. They were unstable blocks, formed from newly born minerals. Vapor condensed into droplets that turned into rain, but as soon as they touched the incandescent ground, they evaporated instantly, returning to the sky in an endless dance between fire and water. That repetition would eventually shape the first hints of what would become the future oceans. Each drop that evaporated and fell again represented an attempt by the Earth to create balance. The interaction between heat and moisture, between rock and gas, generated new chemical reactions. Minerals transformed, metals oxidized, and the planet acquired its own texture, its face, its geological identity. Life did not yet exist, but the stage for it was being carved with mathematical precision. The Earth was a natural laboratory, boiling with energy, pulsing to a cosmic rhythm. Everything that existed was fire and will, the will of the universe itself to keep creating. And so in the silence between one eruption and another, beneath a starless sky and a surface of living magma, the Earth began to fall slowly asleep. The heat diminished, the violence subsided, the crust consolidated in certain places. The planet took its first breath. It was not the breath of life, not yet, but it was the sound of the birth of life's future home, a world without form, without soul, and without its own light, preparing to shelter the impossible. For hundreds of millions of years after the birth of the sun, the solar system was still a battlefield. Thousands of rocky bodies, remnants of the primordial disk, crossed space on unstable trajectories. Some orbited in silence, but others collided, exploded and fused, creating new worlds or destroying old ones. The Earth, still in formation, was the primary target of this cosmic fury. Gigantic rocks, some the size of continents, plunged at high speed through the young atmosphere, releasing such immense energy that the entire planet trembled. This was the era of the late, heavy bombardment, a rain of fire and stone that would last for hundreds of millions of years and would forever shape the face of our world. Each impact was a cosmic catastrophe. When one of those asteroids struck the planet, the energy released was equivalent to billions of nuclear bombs. The ground melted instantly. Craters opened with thousands of kilometers in diameter, and incandescent fragments were launched back into space, only to fall again. The air turned into a whirlwind of flames, and the youthful crust cracked like glass under extreme heat. No structure remained for long. The Earth was constantly rebuilt and destroyed, like a living sculpture hammered by the invisible hands of the universe. Each impact reignited the seas of magma, evaporated water, and hurled toxic vapors into the atmosphere. It was a cycle of death that prevented any complete cooling. Yet there was something necessary in that inferno. The bombardment was not only destruction, it was also seeding. The asteroids and comets that fell upon Earth brought more than iron and rock. They carried frozen water, carbon, nitrogen, phosphorus, and complex organic molecules created in other regions of space. With each collision, those elements were released and mixed into the planet's seething surface, enriching it with chemical ingredients that would later become vital for the formation of life. Paradoxically, cosmic chaos was fertilizing the Earth. Fire and violence were preparing the ground for the miracle of biology. It was as if the universe, in its brutality, knew what it was doing. Meanwhile, the moon was also taking shape. Many scientists believe that one of the largest impacts of that era gave rise to our natural satellite. A body the size of Mars, called Theia, would have collided with Earth, launching into space a colossal cloud of incandescent debris. Those fragments agglutinated, and under the pull of gravity formed the moon. Its presence stabilized the planet's axis of rotation, moderating the seasons and creating the first tides. Thus, from destruction came harmony. The impact that could have ended Earth's story was, in truth, the beginning of its balance. Chaos, once again, was the instrument of creation. The skies of that time were a terrifying spectacle. From the horizon arose trails of light that crossed the flaming firmament. Every second was accompanied by flashes, explosions, and shock waves that reverberated for thousands of kilometers. The air shook, the ground melted, and the sound of collisions echoed across the planet. It was a constant roar, an endless thunder. And even so, within that scene of destruction, something silent and profound was happening. The number of impacts slowly began to decline. Chaos, though still present, began to organize itself. The space around the sun became cleaner, the orbits more stable, and the large fragments less numerous. The solar system, finally, was maturing. When the bombardment began to subside, Earth emerged transformed. Its surface was still a mosaic of lava and craters, but the energy had diminished enough to allow the beginning of a new process, global cooling. The thick clouds of vapor began to condense, and an endless rain fell upon the planet. Droplets accumulated in craters and in melted valleys, forming puddles, lakes, and finally the first seas. The water brought by comets and released by volcanoes began to cover the forming crust. From fire, the ocean arose. For the first time, Earth felt the cold touch of water. Hell was beginning to give way to calm. Even so, the planet still bore deep scars. The internal heat remained intense, and volcanic eruptions continued to expel poisonous gases. The craters, now filled with boiling water, released incessant vapors. The atmosphere became dense and murky, composed of carbon dioxide, ammonia, and methane. It was a heavy, red, and thick sky. Sunlight barely crossed it. Yet that toxic layer was, curiously, what made the planet habitable in the long run. It retained heat and protected the surface from solar winds, creating a natural shield. The same gas that would prevent a human from breathing was what kept the planet from dying frozen. The balance was fragile but real. With the end of the bombardment, Earth fell asleep for the first time. The planet that once roared now whispered. The crust began to stabilize, and the first minerals crystallized into solid layers. The rain continued, incessant, covering the planet in shallow, warm oceans. Fire had given way to water, and the sound of explosions was replaced by the sound of drops. Yet even in the calm, the past still burned inside the planet. The metallic core spun, keeping heat alive. Magma, silent, still moved beneath the crust. And above all, the universe watched. The Earth, wounded and shaped, was ready to take the next step, the birth of the seas and the first breath of the chemistry of life. The sun that illuminated the early Earth was not the calm and stable star we know today. It was a young, turbulent, and explosive star, and each of its eruptions hurled waves of radiation and charged particles throughout the solar system. These stellar storms swept through space with a force capable of destroying entire atmospheres. The Earth, still fragile and unfinished, was constantly struck by this violent solar wind. Rays of plasma traveled millions of kilometers, colliding with the young atmosphere and tearing away entire molecules. The planet lived under an invisible bombardment, coming from the very star that gave it light. It was an era in which the sun was both creator and destroyer, a god of fire and wind shaping the destiny of Earth. With each solar eruption, the space around the planet became a field of pure energy. Subatomic particles pierced the thin atmosphere, ionizing gases and producing flashes of green and violet light that danced across the sky like violent auroras. The surface was constantly exposed to radiation, and no kind of organic molecule could survive for long. The heat, combined with the impact of solar particles, evaporated gases and broke apart the chemical compounds struggling to form. It was an impossible balance. Earth tried to create stability, but the sun stripped it layer by layer, turning the planet into a vulnerable body. Even the magnetic field, just beginning to form within the metallic core, was still too weak to contain such fury. The solar wind is a continuous breath of particles expelled from the sun's corona, electrons, protons, and ions traveling at speeds greater than 400 kilometers per second. During the first billions of years, this flow was hundreds of times stronger than it is today. It struck the planet with enough energy to sweep away light gases like hydrogen and helium, preventing them from accumulating in the atmosphere. This is why Earth did not retain the same gases that make up the giant planets like Jupiter or Saturn. Instead, what remained were the heavier elements that the wind could not carry away: carbon dioxide, sulfur, and water vapor. The selection imposed by the sun defined the chemical destiny of the atmosphere. The star, in its violence, was sculpting the conditions of the future, but there was one force that resisted: the magnetic field. In the heart of the planet, the liquid iron core spun rapidly, generating electrical currents that created an invisible shield, the magnetosphere. It deflected part of the solar wind, forming a protective bubble around Earth. Without that field, the planet would have lost its atmosphere completely, just as Mars did billions of years later. The magnetosphere became one of Earth's greatest defenses, protecting it not only from solar winds, but also from cosmic radiation. Still, in this early stage, protection was imperfect, and every solar storm left deep scars. The sky would light up with flashes, and the wounded planet continued its slow struggle for survival. Solar eruptions were so intense that they could alter the global climate. Radiation heated the upper atmosphere, while the impact of charged particles generated colossal electrical discharges. Lightning crossed the sky with enough intensity to split molecules and create new compounds. It was within that electrical chaos that many fundamental chemical reactions began to occur. Simple gases like methane, ammonia, and water vapor collided under electric discharges, forming complex organic molecules, the building blocks of life. Paradoxically, The same sun that destroyed the atmosphere also helped create the ingredients of biology. Fire and light once again played a double role, destruction and genesis. For millions of years, the planet lived in this fragile balance between heat and wind, between erosion and creation. Solar storms alternated between calm and fury. With each cycle, the atmosphere rebuilt itself, denser and more resistant. Volcanism released new gases from the planet's interior, replacing what the sun had stripped away. The Earth seemed to learn to breathe again. This endless exchange between the inside and outside of the planet created a geological and cosmic dance. The sun breathed and Earth responded. The energy that came from outside mixed with the energy that came from within, and together they shaped the planet's identity. As time passed, the sun began to mature. Its intensity stabilized and the solar wind lost some of its strength. The atmosphere, now thicker, became capable of retaining heat and moisture. The sky, once filled with plasma and particles, began to clear, revealing a softer yellowish light. The planet finally began to breathe regularly. The storms still existed, but they were no longer able to strip the world bare. The strengthened magnetosphere deflected the most violent flows, and the crust began to expand and solidify in a stable way. Hell was giving way to dynamic balance. For the first time, Earth could begin to build something permanent. From space, a silent observer would witness a fascinating spectacle. A bluish-red sphere wrapped in vaporous clouds, spinning slowly beneath the light of a furious star. This was Earth about 4 billion years ago, a planet of fire, yet full of potential. Every solar storm, every impact, every eruption, every evaporated drop was part of a single process, the birth of complexity. Chaos, as always, was simply the language the universe used to create order. And in the heart of that cosmic fire, life, still non-existent, was already waiting for its moment. After the asteroid bombardment and the solar storms that nearly destroyed the newborn planet, the Earth began to transform. The liquid hell that covered its surface slowly started to solidify. From the still seething interior, volcanoes spewing fire and ash scarred the skin of the forming planet. With each eruption, the ground trembled and the sky thickened. From the depths emerged gases trapped since the birth of the crust: water vapor, carbon dioxide, methane, ammonia, and sulfur. This toxic mixture, released in incessant eruptions, began to form a dense haze that wrapped the entire planet. It was the birth of the first terrestrial atmosphere, an invisible mantle that, although poisonous, would be essential for everything that would come afterward. The air of the primordial Earth was lethal, a hot and suffocating vapor that no living being could breathe. There was not yet free oxygen, nor a blue sky, nor a gentle breeze. The atmosphere was a chemical cauldron, dense and heavy, filled with gases that trapped heat and imprisoned energy within the planet. Carbon dioxide dominated the air, creating a brutal greenhouse effect that prevented the loss of heat to space. The surface temperature remained extremely high, and the seas of magma still exhaled toxic vapors. Yet paradoxically, that same poisonous mantle allowed the Earth to endure. It shielded the planet from direct solar radiation, prevented total freezing, and maintained the energy needed for the future chemical transformations that would give rise to life. The scene was terrifying. Volcanoes launched columns of ash to tens of kilometers in height. Lightning cut the sky, producing electrical discharges so intense that they illuminated the entire planet. The rain, when it fell, was not pure water, but acid and vapor. The clouds were formed by particles of sulfur and volcanic dust. The smell of ammonia and metallic gases dominated the air. It was the sound of creation, the deep noise of a planet learning to breathe. Each thunderclap, each explosion, each flash was a chemical reaction taking place on a global scale. Fire and electricity mixed with vapor and gas, transforming chaos into alchemy. The planet was boiling, yet also cooking the foundations of life. The first drops of rain that managed to resist the heat began to fall on the incandescent ground. They evaporated almost instantly, turning into clouds of vapor that condensed again in the sky. This cycle of evaporation and condensation repeated for millions of years, until the crust cooled enough for part of the water to remain liquid. The craters and valleys left by ancient impacts began to fill, forming puddles and temporary lakes. It was the beginning of the long process that would create the oceans. The water brought by comets and released from the rocks was now beginning to find its place. The acidic rains, once destructive, began to sculpt the surface and react with minerals, releasing salts and nutrients that would enrich the future aquatic environment. Meanwhile, the Earth's interior remained a beating heart of fire. Heat from the core melted rock and kept the volcanoes active. Each eruption released new layers of gas, thickening the atmosphere and intensifying the greenhouse effect. The temperature, although still extremely high, began to stabilize within a range that allowed the continuous condensation of vapor. The planet was, for the first time, creating a climate cycle. The sky became a living boiler. Vapor rose, condensed, fell as rain, and returned to the ground only to evaporate again. It was a steady rhythm, a pulse between fire and water. This unstable balance would be the first rehearsal of what we call climate. During this period, electrical discharges in the skies were constant. Lightning crossed the dense clouds, generating enough energy to break and reorganize simple molecules. Ammonia and methane reacted with water vapor, producing primordial organic compounds such as amino acids and simple sugars. These reactions, driven by heat, electricity, and ultraviolet radiation, began to create the chemical broth that would later become the cradle of biology. No living being existed yet, but the ingredients of life were already being mixed in silence amid the storms. The planet, unknowingly, was preparing for the greatest event of all, the emergence of living matter. As millions of years passed, the Earth's sky began to change. Volcanic ash slowly dispersed, and the vapor formed thicker and more uniform clouds. Rain became constant, feeding lakes and shallow seas. The temperature gradually fell, and the ground began to solidify into broad basaltic plains. For the first time, the planet possessed a stable water cycle, even if still simmering. Nights became less bright, and the sun, filtered by the dense layers of gas, lit the surface with a reddish, almost ethereal glow. It was a strange world, where the sky was never blue and the rain never ceased. A planet covered in vapor, yet already carrying at its core the first signs of serenity. And so amid thunder, lightning, and seething seas, the Earth took its first true breath. The atmosphere, still poisonous and hot, had become permanent. The water that once evaporated upon touching the ground now remained, accumulating in deep depressions. The cycle between fire and vapor finally found balance. The planet was ready for the next step, the creation of the oceans and the birth of the chemistry that would transform the inanimate into life. Hell was beginning to give way to hope. The sound of the rains, once a symbol of destruction, now became the sacred rhythm of creation. The rain fell for thousands of years without cease. Drop after drop, the vapor that once suffocated the sky condensed into relentless torrents that crashed against the planet's still hot crust. Earth's surface hissed like incandescent metal plunged into water. Every drop that touched the ground evaporated, rising back as cloud. It was a cycle of fire and vapor, of birth and destruction. And little by little, amid bursts of steam and distant thunder, the first seas began to take shape. Primordial oceans of boiling water, covering the planet like a thick and living mantle. For the first time, Earth began to see itself reflected in its own liquid surface. Those first seas were nothing like the ones we know. There was no blue and no calm. The water was murky, dense and dark, saturated with dissolved minerals and heavy metals. The temperature was so high that any modern living being would die instantly. Atmospheric pressure was dozens of times greater than today, and the air was filled with toxic gases. The ocean bubbled beneath an orange sky, lit by continuous lightning and erupting volcanoes. It was a planetary cauldron boiling at temperatures close to the point of ebullition. Even so, it was within that chaos that life would find its natural laboratory. The combination of heat, water, and electrical energy created ideal conditions for the cosmic alchemy that would turn the inorganic into the organic. The sound of Earth was the sound of creation. The roar of volcanoes mixed with the crash of thunder. The boiling sea swallowed incandescent rocks that rolled down from newly formed mountains. Gases escaped from the planet's interior and bubbled up through the liquid depths, creating pockets that burst in jets of steam. The horizon was a constant line of fire, where magma met water and generated dense clouds of ash. Sunlight, filtered by that thick layer of particles, tinted the planet red. Each dawn felt like an endless dusk, and each night was only a continuation of the same luminous inferno. Earth breathed fire, yet it was beginning to learn how to calm itself. The water of those first seas was not only a liquid, it was a rich solution, loaded with chemical compounds delivered by volcanoes and by dissolved rocks. Sulfur, iron, magnesium, and silica mixed in turbulent currents. Hydrothermal vents opened on the seafloor, expelling hot gases and reactive minerals. Around those fissures, the extreme heat and explosive chemistry created unique microenvironments. They were places of abundant energy where simple molecules could combine and react. It was as if the entire planet were an immense chemical reactor in which fire and water worked together to synthesize the fundamental building blocks of biology. The universe had created its first natural laboratory. As the oceans spread, the planet continued to transform. Internal heat still kept the crust in motion, and constant volcanism renewed the surface. The vapor that rose from the waters fed dense clouds that returned as pouring rain. The cycle was self-sustaining. Gradually, the temperature began to fall, allowing the upper layers of water to remain liquid for longer periods. Sunlight reflecting on the vapor drew golden and reddish gleams that danced across the sea surface. Beneath those boiling waters, minerals accumulated in layers and formed primitive sediments, the first records of oceanic geology. The planet was beginning to record its own memory. The impact of storms was constant. Lightning crossed the sky and plunged into the waters, releasing enough energy to provoke large-scale chemical reactions. The air was saturated with methane and ammonia, and each electrical discharge broke these molecules, allowing them to recombine into new organic structures. Amino acids, lipids, and simple sugars began to appear in small quantities, dissolved in the warm waters of the primordial oceans. These substances, still inanimate, were the seeds of biology. What we now call life was beginning to take shape in the depths of a still inhospitable planet. Hell was unknowingly creating paradise. As millions of years passed, the surface of the planet began to stabilize. Storms diminished in intensity, and the rain, although constant, no longer evaporated upon touching the ground. The seas, now deeper and more extensive, covered a large portion of the crust. Sunlight managed to penetrate the haze partially, casting soft reflections over the water. The world, still in a simmer, began to quiet down. Energy that had been destructive became creative. Earth had found a rhythm. Fire still burned in the depths, but water ruled the surface, and within that unstable balance, the conditions that would give rise to life began to take hold. The boiling oceans were at once tomb and cradle. Nothing could live in them yet, but everything that would one day be alive began there. Molecules danced in hot currents, combining and separating in an unconscious chemical ballet. The planet, once pure fire, now blended the heat of destruction with the serenity of water. Mountains exhaled vapor, and the loaded sky hurled incessant lightning over the waves. It was a cosmic spectacle of energy and transformation. Hell had not ended. It had merely become fertile. And when the sun rose, its golden light reflected upon the fuming seas, illuminating an earth veiled by clouds and lightning. Beneath that quivering glow, silently, the first organic compounds formed. No eyes watched them, no being understood them, but the universe in its infinite patience knew what it was doing. The boiling waters would be the womb of the future, the place where, amid fire and storm, life would learn to be born. When the first oceans covered the earth, the sky was still a battlefield. Clouds heavy with vapor and volcanic gases gathered in thick layers, trapping heat and creating endless storms. It was an age when the entire planet thundered. Lightning crossed the heavens every second, tearing through the reddish-orange veil of the atmosphere and illuminating the boiling seas with flashes of white and blue light. The sound of thunder echoed through valleys still in formation, and every electrical discharge made the air tremble. The world seemed alive, breathing in thunder. This was the music of chaos, a natural symphony that echoed across the planet and unknowingly helped create the very essence of life. The energy of these storms was immense. Each bolt of lightning released enough heat and electricity to transform simple molecules into more complex compounds. Ammonia, methane, and water vapor, abundantly present in the primitive atmosphere, were constantly broken apart and rearranged by these discharges. The result was organic molecules, the first building blocks of biology. What we now call amino acids, sugars, and carbon chains began to appear between the flashes of the sky and the bubbling of the seas. The planet was a natural laboratory, and lightning was its catalyst. Each storm was a global-scale chemical experiment, repeated millions of times over millions of years. On the horizon, volcanoes hurled columns of fire and ash that mingled with the storm clouds, creating even more powerful electrical discharges. Electrically charged volcanic dust increased the frequency of lightning. Bolts spiraled down from the sky in streaks of light, striking the sea surface and triggering instant chemical reactions. It was in that cauldron of energy, vapor and minerals, that life took its first invisible silent steps. The heat of magma, the electric shock, and liquid water were the three fundamental elements of cosmic alchemy. Through its own fury, Earth was manufacturing the conditions that on other worlds might never be repeated. For millions of years this scenario persisted. The atmosphere remained charged with electricity, and the sound of thunder never ceased. At night, the sky was a constant storm of light, and dawn broke beneath heavy clouds that seemed to merge with the ground. The cycle was endless. The heat of volcanoes created vapor. The vapor formed clouds. The clouds released rain and lightning created new molecules. Every drop that fell carried within it the products of these reactions, primitive organic compounds dissolved in boiling water. These compounds accumulated in shallow lakes and warm seas, mixing with mineral salts and reactive metals. Slowly, a chemical broth began to form, the cradle of life. In certain parts of the planet, the energy was even more intense. Near volcanic vents, heat and electricity combined explosively. Lightning struck directly into streams of magma, vaporizing minerals and creating new elements. The molten rocks reacted with gases and water, releasing hydrogen, sulfur, and iron, which dissolved into the sea. This mixture fueled chemical reactions that continued long after the storm had passed. Energy left lasting traces, as if each lightning bolt burned a fiery signature into matter itself. It was the universe writing in chemical language the first words of biology. The sound of storms became the background noise of Earth itself. The planet was young, and its voice was thunder. Each explosion in the sky was followed by the roar of the sea, and each flash illuminated a world in turmoil. But there was something profound and symbolic in this chaos, that in the midst of destruction, the cosmos was finding a path to creation. Electricity, raw, unpredictable force, was also a creative spark. The same fire that destroyed mountains was unknowingly igniting the first breath of molecular complexity. Nature had no intention, but it had consequence. And what was once mere chance began to turn into structure, into pattern, into persistence, the prelude to life. As millions of years passed, the sky began to brighten slightly. The clouds grew thinner, and lightning, though still frequent, became more spaced out. The atmosphere, now more stable, trapped heat and allowed liquid water to exist continuously. The sound of chaos gave way to a softer rhythm. The storms that once enveloped the whole planet now occurred in cycles. Even so, their effects remained etched into the waters and rocks. Atmospheric chemistry had prepared the ground. Life did not yet exist, but the planet was saturated with its ingredients. Electricity had fulfilled its role. It had turned lightning into seed and thunder into promise. What remained was the silence between the storms, a heavy silence, broken only by the whisper of warm seas and the distant crackle of volcanoes. In that pause between fire and calm, the planet drifted into rest. But beneath the waves, in the heated, mineral-rich depths, something began to organize itself. The molecules formed by the storms began to link into longer, more stable, more complex chains. And for the first time, chance began to resemble intention. The chaos that once roared now began to whisper. It was the sound of the beginning, not just the sound of chaos, but the sound of creation. Before the first true sunrise, Earth lived beneath an endless night. It was a world shrouded by dense clouds, saturated with volcanic gases and metallic vapors. The light of the sun, intense as it was, barely pierced that opaque curtain. The sky was neither blue nor black. It was a thick mass of red, gray, and scorched orange, in constant motion. The planet was wrapped in its own hot, suffocating breath, and no star could be seen. Space, the sun, the constellations, everything was hidden behind a veil of storm and vapor. Earth was an isolated bubble in the cosmos, a sphere of fire and mist lost in the dark. The clouds that covered the planet were a direct result of volcanic fury and internal heat. Gases like carbon dioxide, sulfur, and methane formed heavy layers that trapped warmth and scattered light. The surface remained incandescent, and water vapor, in constant evaporation, thickened the atmosphere. It was like living beneath the roof of a furnace. Heat did not escape, and light did not enter. The sun rose and set without being seen. No golden dawn lit the mountains. No moonlight touched the seas. Earth existed submerged in a permanent twilight in which day and night were indistinguishable. It was the silence before light, a hot, oppressive, absolute silence. In that stifling environment, atmospheric pressure was colossal. The weight of gases upon the surface was so great that the air behaved almost like an invisible liquid. The lowest clouds were formed by metallic vapors and ash particles. Lightning crossed the sky in continuous lines, yet their glow was diffuse, reflected by the dense haze. No shadow existed, for there was no defined direction for light. Brightness came from everywhere and from nowhere. Earth seemed to live inside itself, isolated from the universe, turning within a cocoon of heat and solitude. It was a luminous prison, where radiance blended with darkness. The sound of that age was deep, muffled, and constant. The dense air carried vibrations as if the planet itself had a heart. The distant roar of volcanoes merged with the voice of boiling seas. Rain, when it fell, was neither cool nor comforting. They were hot, almost vaporous drops that evaporated upon touching the ground. And yet, even amid that inferno, the planet began to change. The crust thickened, heat dissipated slowly, and the densest clouds began to rise. Storms, once unending, grew less violent. It was a slow process, almost imperceptible but constant. The world began to brighten, not by light but by patience. The absence of stars shaped a sensation of total isolation. If an observer could have existed then, they would have seen nothing but a pulsating reddish horizon. The sun would be only a diffuse blot behind the clouds, a presence felt as heat rather than sight. Nights would be an endless darkness, cut by the sporadic glare of lightning. It was as if the planet had not yet been granted permission to look back at the universe. Earth was in gestation, and its sky was the womb that protected it. Within that opaque shelter, elements continued to react, molecules continued to combine, and silence prepared the stage for the first spark of biology. The opacity of that sky also had a purpose. The absence of direct light kept the surface from being scorched by the ultraviolet radiation of the still violent young sun. The thick layers of vapor and gas acted as a natural shield, protecting the newborn waters and the delicate molecules accumulating within them. It was in that protective darkness that the chemistry of life began to mature. The planet was in incubation, sheltered by its own chaos. What seemed suffocating and destructive was, in truth, the isolation required for the miracle to develop safely. The starless night was not an ending. It was the beginning of the wait. As millions of years passed, the sky slowly began to clear. Heavier particles dispersed, and sunlight started to enter in timid shafts. The first golden reflections crossed the haze and touched the warm waters, drawing shimmering gleams upon the seas. The planet remained veiled in vapor, but for the first time direct sunlight reached the surface. Earth stirred from its deep sleep, still wrapped in mists, yet already able to perceive the presence of the cosmos. The veil began to lift, and the world, which had lived in silence and shadow, prepared to meet the light. The first true sunrise was still distant, but its promise already existed. The sky, blind for ages, now rehearsed its first glimpse of the universe. And when the stars returned to shine, when the sun was finally visible, Earth would already be ready, with seas, an atmosphere, and the chemical embryo of life within. The end of darkness would not only be the birth of light, but the awakening of the cosmic awareness of a planet that, after so much fire and shadow, would finally learn to see. When the thick veil of the sky began to fade, Earth was no longer the same world of fire that had once ruled the silent expanse of space. The crust, once liquid and incandescent, began to harden. Rocks solidified, forming scattered islands over still boiling seas. Each fragment of land was unstable, fragile, and constantly shifting. Beneath the surface, magma continued to flow in slow currents of heat, pushing and breaking what had already formed. It was the beginning of tectonics, the silent movement of the planet's inner body. Earth was learning to move, to breathe through its fractures, to pulse from within like a growing organism. These first tectonic plates were only sketches, irregular blocks of rock floating over an ocean of magma. They collided, separated, and merged incessantly. Each impact reshaped the crust, creating ridges, valleys, and fissures. The inner heat forced the seafloor to split into long, glowing scars where magma rose and spread. With every submarine eruption, the ground expanded, pushing what lay around it. It was a continuous cycle of destruction and renewal. The planet was a living machine, forever in motion, seeking balance. Nothing stayed still. Earth's very surface was a battlefield of geological forces. In the boiling oceans, the effects of these forces were visible. Hydrothermal vents exploded in columns of steam, releasing minerals and heat into the water. Around these fissures, the sea bubbled and shimmered with metallic colors, yellow, black, copper, red, the result of chemical reactions between magma and salt water. Gases like hydrogen sulfide and methane escaped, creating toxic yet energy-rich environments. In these extreme regions, the chemistry of life found fertile ground. The intense heat and dissolved minerals served as fuel for the first organic reactions. It was the most efficient natural laboratory in the universe, the meeting point between rock and sea, between fire and water. Meanwhile, the crust continued to reorganize. Denser regions sank while others rose. Small continental fragments began to take shape, still covered by shallow, warm seas. The surface was unstable and fractured, but already showed the pattern that would mold the planet for billions of years to come. Every movement of the crust released energy. Every crack allowed heat to escape, and this dynamic balance helped cool Earth's interior. It was a slow, almost imperceptible process, yet inevitable. Life, still non-existent, was finding a stable home, one still bathed in fire. The air above those seas was heavy and humid. Thick clouds covered the horizon, and thunder still rolled across the sky, though less often. Sunlight, filtered through the vapor-laden atmosphere, cast golden and reddish hues upon the murky waters. At each sunset, the planet seemed to breathe in mist and smoke. The thermal energy was so great that the waves seemed to boil. Water, rich in mineral salts, dissolved metals from the rocks and carried them into the depths, where new chemical reactions occurred. In every corner of the planet, the interplay between geology and chemistry wrote the first lines of Earth's long story. The metallic core spinning at the planet's heart strengthened the magnetic field. This invisible shield protected the atmosphere from solar winds and prevented essential gases from escaping. It was this magnetic field that ensured the persistence of the atmosphere, of water and later of life. Earth was gradually becoming a complete planet, with defined internal layers, with enough heat to sustain geological motion, and with stability to maintain liquid oceans. The crust was its face, the mantle its body, and the core its heart. The planet at last had its own identity, a living anatomy that would forever distinguish it. Even so, the surface remained a world of extremes. In some places, magma gushed through fissures, forming incandescent rivers that met the sea, producing bursts of steam. In others, the ground began to solidify into vast rocky plains. The heat waned, but the energy remained intense. Acidic rains still fell, dissolving minerals and sculpting the terrain. It was a sculpture carved by time and patience. With every million years, the planet grew more stable, more complex, more prepared for the next step. The embryonic tectonic plates would continue their slow dance, opening seas, raising mountains, and renewing the cycle of creation. Beneath the surface, in the warm, mineral-rich depths, the ingredients of life accumulated. Organic molecules drifted through the waters, reacting and recombining. Some began to form longer chains, others clustered into fragile structures. Life had not yet begun, but its chemistry was spreading across the planet like a seed ready to germinate. The movement of tectonic plates recycling rocks and heating the oceans kept this process in constant renewal. The fire within and the water above worked together, preparing the cradle for the first living being on Earth. The planet, now complete, waited only for the right moment to awaken. And so, amid vapor and stone, between boiling seas and distant lightning, Earth steadied its heart. The sound of magma softened, thunder grew rare, and the clouds began to part in intervals. After billions of years of chaos, the planet began to calm. It was the dawn of a new age, an age when fire would yield to chemistry and chemistry would give birth to life. The world had learned to breathe. And its next breath would be the first sign of something alive. After billions of years of fire, impacts, and electric storms, Earth began slowly to cool. The heat that once made the ground boil and the air glow started to dissipate into space. The core still burned like a living furnace, but the crust was now solid enough to endure the touch of rain. And then the sky, heavy with vapor and memories of chaos, opened completely. From the vastness of the clouds, a rain began to fall, a rain that would not end soon. Drop by drop, the planet was covered by endless waters, in a deluge that lasted thousands of years. It was the purification of the world. Fire yielded to water, and Earth for the first time felt the silence of cooling. This rain was neither light nor gentle. They were unending storms, with thunder fading into the horizon and lightning tearing through the dense air. The drops were hot, loaded with dissolved minerals, and fell with the strength of an entire universe trying to extinguish the fire that had created the planet. The oceans, still boiling, began to absorb this new water, expanding across valleys and craters. The sound of rain blended with the whisper of waves and the distant rumble of volcanoes. It was the sound of transformation, the rhythm of Earth in its first rest. Gradually, the heat gave way, the vapor thinned, and the atmosphere became less suffocating. The planet fell asleep under the weight of clouds. The surface temperature dropped slowly but steadily. Where once there had been seas of lava, there were now expanses of black rock covered in warm water. The hardened crust began to crack, allowing rain to seep deep within, cooling the lower layers. This contact between internal heat and external water produced abundant vapor that rose again to the sky and returned as more rain. It was an endless cycle, a heart of stone and steam beating in constant rhythm. The planet was breathing for the first time in harmony, and as this happened, the first stable rocks, the true foundations of Earth, began to form. These rocks were silent witnesses to the birth of the world. Crystals of zirconium found billions of years later would preserve in their structure the memory of that time. Within them would be engraved the traces of cooling, the chemical marks of the first liquid water, the echo of a rain that never ceased. Every fragment of rock formed in that age is a physical record of the transition between inferno and serenity. Earth ceased to be only fire and became stone, water, and time. From this balance, the natural cycles began to emerge. The cycle of rain, of wind, of tides. It was the first rehearsal for what, billions of years later, would be climate. The volcanoes, once countless and furious, began to fall silent. Some continued to exhale gases, but eruptions became less frequent. The planet seemed weary, exhausted from its own creation. The water vapor in the air formed dense and continuous clouds, and the sky remained covered, as if the sun had disappeared. Under this constant gloom, the seas expanded. The rain washed toxic gases from the atmosphere, dissolving ammonia, sulfur, and carbon dioxide into the water. The planet was becoming less hostile, more temperate, more chemical than explosive. The sound of thunder gave way to the steady rhythm of raindrops. It was the prelude to calm, the first night of rest for the world. Over time, Earth became an immense ocean. The waters covered almost the entire surface, leaving only small islands of solid rock emerging here and there. These rocky masses would be the embryos of the first continents. The rains, now less violent, continued to fall regularly, feeding the seas and maintaining a stable temperature. Vapor rose, condensed, and fell again. A perfect cycle. For the first time, the balance between the sun's energy and the planet's internal heat allowed water to remain liquid for long periods. This was the turning point in Earth's history, the moment when fire yielded definitively to water and chaos to stability. On the surface, the waters no longer boiled but were still warm, like a living ocean. Beneath them, hydrothermal vents remained active, heating and enriching the sea with minerals. The combination of heat, vapor, and nutrients created an ideal environment for increasingly complex chemical reactions. Organic molecules formed by lightning and heat found a new home in these calm waters. There they began to accumulate, mix, and react. Life did not yet exist, but its ingredients were already being gathered. The rain that fell from the sky carried not only water, but also carbon and nitrogen, the basic elements of biology. The storm itself was an act of sowing. The planet had at last found a rhythm. Internal heat balanced the cold of space, and the cycle of rain kept the temperature in harmony. The crust no longer melted, the seas no longer evaporated, and the atmosphere was no longer just smoke. It was the beginning of a new phase, a stable, humid Earth, alive in potential. The world that once roared now whispered. The sound of rain became the sound of time. Each drop that fell was a second in the cosmic clock of creation. And when at last the clouds began to thin and the first ray of light pierced the sky, Earth looked upon itself for the first time, covered in seas, wrapped in mist, serene. The planet had awakened from fire and been born of water. While the rains fell upon the planet and the seas expanded, the space above still did not rest. The young and turbulent solar system continued to hurl toward Earth the fragments of its own creation. Comets and asteroids crossed the void in chaotic trajectories, many of them colliding with the surface of the newly cooled planet. Unlike the bodies that had once devastated Earth during its first billions of years, these visitors brought something different: ice. Blocks of frozen water mixed with dust and organic compounds came from the cold regions of space, from the distant frontiers where the sun was only a faint star. Each impact carried a gift. Small amounts of stellar water crystallized, melting upon contact with the crust's heat. It was the water of the stars falling upon Earth. These comets were messengers of cold and time, formed from the remnants of the primordial disk of gas and dust that once surrounded the sun. They preserved within their cores the same ice that existed at the birth of the solar system. When they collided with Earth, part of this ice melted, releasing water vapor and gases that nourished the atmosphere. Another part mixed with the seas, increasing their volume and altering their chemical composition. The impact of millions of these celestial bodies, over hundreds of millions of years, delivered a considerable portion of the water that still covers the planet today. Each drop in the oceans carries within it a fragment of that cosmic heritage. When we touch the sea, we touch the physical trace of the stars. The chemistry of these stellar waters was different from the water formed by volcanic reactions on Earth. They carried traces of deuterium, a heavier form of hydrogen, typical of the cold regions of space. This subtle signature, preserved in the molecules, would become the unmistakable mark of their cosmic origin. Modern studies, billions of years later, would confirm that part of Earth's water came from these icy visitors. Alone, the planet could never have produced such a vast quantity of vapor, with its internal heat. It was the universe itself, through its crumbs of ice and dust, that completed the work. Just as a body needs blood, the planet needed the touch of the stars to become what it is. These collisions, however, were far from gentle. Each comet that struck Earth released energy equivalent to the explosion of thousands of volcanoes. The surface trembled, the seas rose in colossal waves, and vapor soared upward in pillars of fire and smoke. The planet shuddered, yet it was also nourished. Every impact added new substances to the primordial broth: carbon, nitrogen, phosphorus, and simple organic compounds. These molecules, brought from afar, mixed with those already present in Earth's warm waters, enriching the chemical environment even further. The entire cosmos seemed to conspire to create life. Space, once a source of destruction, had become a source of nourishment. As millions of years passed, the bombardment of comets subsided. Earth had gathered what it needed. The oceans were complete. The planet now shone under the light of the sun, covered by seas that reflected both the golden glow of the star and the grey of the clouds. Every wave carried within it a fraction of stardust, dissolved, invisible, yet real. It was a profound connection. The planet was literally made of the same material as the cosmos. The waters falling from the clouds were sisters to the frozen waters that traveled between worlds. The cycle of life, though it had not yet begun, was already intertwined with the universal cycle. The rain of Earth and the ice of comets were two sides of the same origin. These united waters shaped the destiny of the planet. From them emerged the chemical reactions that would later create the first self-replicating molecules. They infiltrated rocks, dissolved minerals, and formed oceans rich in salts and nutrients. In the deep, hot abysses, the heat from hydrothermal vents transformed what the comets had brought into living chemistry. Water, which had begun in the clouds of stars, now became the blood of Earth. Everything that exists, mountains, forests, organisms, owes its existence to this cosmic union between the fire of the planet and the ice of the universe. Life, in its essence, is a memory of the sky. Today, billions of years later, every molecule of water circulating through our bodies carries traces of that journey. Part of it came from Earth's interior, formed in ancient volcanic reactions. Part came from space, brought by comets that once crossed the skies of the past. And both were forever blended. When the rain falls, it repeats the cycle that began among the stars. When a river flows, it echoes the movement of ancient cosmic streams. And when the sea touches the sand, it reenacts the gesture of billions of years ago, when the universe bestowed upon the planet the gift of liquid life. Fire created the body of Earth, ice created its soul, and from that union of extremes was born what we call home, a blue planet, shaped by light and darkness, and bathed in the waters of the stars. After ages marked by fire, collisions, and thunder, the planet began to rest. The heat within still burned, but the fury of the surface gave way to serenity. The rain had fulfilled its purpose. It had washed the sky, filled the seas, and dissolved the poisons of ancient eruptions. The vapor that once suffocated the atmosphere began to thin, allowing the light of the sun for the first time to pass clearly through the thick veil of clouds. The horizon was no longer only red and grey. It became golden, diffuse, almost gentle. The world began to see its own brightness. It was the end of hell and the beginning of calm, the first dawn of a planet that after billions of years of turmoil was finally falling asleep in balance. During this period, known by geologists as the era of great cooling, the surface heat slowly dissipated into space. The crust hardened, solidifying into vast basaltic plains, while ocean temperatures dropped to levels close to chemical comfort. The water, once boiling, became warm and stable, allowing the previously formed organic compounds to survive longer. Ocean currents established themselves, creating a natural flow between hot and cold regions. The planet, for the first time, breathed with its own rhythm, alternating luminous days and true nights. Earth, which until then had known only chaos, was discovering silence. The cooling was not an abrupt event, but a slow symphony. Each layer of the Earth reacted in its own time. The regions closest to the core remained blazing, maintaining the magnetic field and feeding the gentle volcanism that still persisted. Meanwhile, the surface grew increasingly solid. The embryonic plates, once born from heat, now slid softly beneath one another. The planet was learning to move with stability. Beneath the seas, hydrothermal vents continued to expel heat, but in a controlled way, creating zones of distinct temperature and chemistry. At these borders between hot and cold, nature began to test the limits of matter, a silent prelude to the emergence of life. The sky, too, began to change. The air, once heavy with ash and sulfur, gradually cleared. The atmospheric density decreased, and the first bluish tones began to appear above the clouds. Sunlight, filtered through a thinner veil, started to paint the planet in soft shades of gold and copper. The sun, visible for the first time, cast reflections across the warm seas, and the glimmer danced upon the waves as if the earth were learning to smile. Solar energy, now steady and less violent, began to fuel chemical reactions in the surface waters. The atmosphere, still toxic, was becoming more hospitable. It was the first rehearsal of climatic balance. During this period, Earth's surface was already showing contrasts. Regions near volcanic sources remained warm and active, while distant areas experienced mild temperatures. This contrast generated winds, currents, and gentle storms, the first atmospheric cycle. The sound of Earth was no longer the roar of explosions, but the constant murmur of wind and the distant echo of waves. With every sunrise, the planet seemed to awaken more mature, more serene, more aware of its own shape. The waters, now stable, reflected the sky, creating a harmony that had never existed before. The fire that had once shaped the planet now warmed it from within without destroying it. The rocks formed during this time would become the oldest known, and billions of years later, they would be found as silent witnesses of this tranquil birth. Within their chemical composition, they would bear the traces of the first interaction between the ocean and the solid crust. Each crystal, each mineral, would be a reminder that before life there was a long and patient silence. This interval of calm was essential. Without it, no molecule could have survived the tempests of the past. It was in rest that chemistry organized itself. It was in the cold that chaos turned into structure. The serenity of the planet was the cradle of complexity. In the sky, the rain continued to fall, but now in a steady rhythm like a song. The clouds drifted slowly, and thunder no longer frightened. The water cycle was complete. Evaporation, condensation, and return. A liquid heart beating above the crust. This simple and eternal cycle would become the foundation of life. Over time, the vapor that rose to the heavens helped form a thin layer of gases that would protect the planet from the most intense radiation. Earth, without realizing it, was creating the conditions for the miracle. Everything that had been destruction became protection. Everything that had been fire became warmth. Everything that had been chaos turned into order. And when the sun shone upon the surface for the first time, without being hidden by clouds or ashes, its light reflected over the seas and flooded the planet with brightness. Earth was calm. The noise of eruptions had ceased. The sound now was that of water touching rock, of wind gliding across the waves, and of the silence that precedes creation. The planet had passed through hell and emerged transformed. It was now a blue world, covered in tranquil seas and a gentle atmosphere. The fire still burned within, but the surface was at peace. And in that peace, in the warm and deep waters, the invisible began to awaken. The next step would be the most important of all, the moment when chemistry would become biology. When the planet finally calmed, something extraordinary began to happen. From the fusion of fire and water, from unimaginable pressures and slow cooling, the first stable rocks were born. They were solid fragments of a world in transformation, the physical testimony of a hellish past that was beginning to turn into order. These primitive rocks were the Earth's first memories, silent records of a planet that had learned to exist. They formed in shallow seas, across basaltic plains and along the edges of dormant volcanoes. Each crystal was a trace of imprisoned fire, each grain a remembrance of a time when the entire world breathed magma. These rocks, now known as the oldest on the planet, hold a story written not in words but in structure. Within them lie the clues to the first cooling, the first rains, and the first oceans. In places like northwestern Canada, the interior of Greenland and Western Australia, modern geologists have found zircon fragments more than 4 billion years old, minuscule particles capable of telling the beginning of everything. These crystals survived ages of destruction, burial, and melting, as if the planet itself had hidden within them the memory of its birth. Each atom of oxygen, each crystalline arrangement reveals an ancient truth. Earth began as a fiery world, but cooled enough to sustain water, and later, life. The formation of these rocks was both slow and violent. As magma began to cool, minerals crystallized, separating by density. The heavier ones sank while the lighter ones remained on the surface, forming distinct layers. The result was a solid, dense, and resilient crust, capable of withstanding the pressure and heat rising from within. As the crust thickened, small rocky islands emerged from the oceans, becoming the first fragments of land. These blocks would, millions of years later, become the embryos of future continents. It was the planet learning to organize itself, building, stone by stone, the foundation of the world we know. Rock is, in essence, Earth's diary. Each mineral is a sentence, each crystal a word. By studying them, scientists can read time itself. The proportions of their elements reveal temperature, pressure, and even the composition of the atmosphere at the time they formed. They tell us that the planet, once a furnace of fire, already had liquid seas and a stable climate less than 500 million years after its birth. This discovery changes everything, for it shows that life could have emerged much earlier than once believed. Cooling happened quickly, and the environment suitable for biology was established soon. What once seemed improbable became inevitable. Earth had become fertile. These rocks also hold the traces of the first chemical reactions between the crust and the ocean. When acid rain fell upon the basaltic plains, it dissolved minerals and carried metals into the sea. The contact between water and rock generated new compounds, silicates, carbonates, sulfides, enriching the oceans and altering their composition. This is how the primordial sea gained color, density, and nutrients. As the rocks eroded, they fed the ocean, and the ocean in turn sculpted the rocks. It was a harmonious cycle of mutual creation. The planet recycled itself in search of balance. Raw matter was becoming aware of its own transformation. Over millions of years, these rocks began to reorganize. The pressure of the embryonic tectonic plates caused them to fuse, fold, and re-emerge in new forms. The heat from the planet's interior metamorphosed them, creating more complex and resilient minerals. The crust became a living tapestry of rising mountains and valleys, sinking under the weight of time. With each cycle, the planet erased part of its history, but never completely. Traces always remained. Preserved crystals, fragments trapped in deep layers, mineral fossils of time itself. Even without life, Earth was already leaving traces of itself. It was learning to remember. These mineral memories are what now allow science to retell the world's childhood. They are the voices of deep silence, the witnesses of a past no creature ever saw, yet one that shaped everything. When we look at an ancient rock, we see time solidified. We see magma turned mountain, sea turned crystal, thunder turned stone. They are proof that the universe creates nothing in vain. Each geological layer is a page in the book that began more than 4 billion years ago and continues to be written drop by drop, eruption by eruption, century after century. The first rocks were not merely inert matter. They were the first record of stability, the first sign that the planet had survived itself. Fire had given way to form, and form to time. Earth ceased to be only a body of flames and became an entity with memory. Everything that would come later, the deep oceans, the rich atmosphere, and life in all its forms, would be born upon this silent foundation. And when much later life learned to walk upon them, those same stones would still be there firm, remembering what the universe had to endure so that the first being could breathe. After billions of years of fire and storms, Earth, now wrapped in warm and stable seas, became the most extraordinary natural laboratory in the known universe. The rains had carried minerals from the newly formed rocks, slowly dissolving them into the waters. Volcanic eruptions continued to expel gases and chemical compounds from the planet's interior. The sun sent light and heat in just the right measure to keep the surface liquid, and the electrical energy of lightning, combined with ultraviolet radiation, fueled relentless reactions. The result was a living ocean in motion, a cauldron of elements, molecules, and energy. In this chaotic yet fertile environment was born what scientists would later call the primordial soup, the chemical broth where the impossible began to become inevitable. The warm waters were filled with simple compounds: ammonia, methane, carbon dioxide, hydrogen, sulfur, and phosphorus, all constantly reacting with one another. The energy released by lightning, volcanoes, and hydrothermal vents broke the bonds of these substances and rearranged them into new combinations. Every second, trillions of chemical reactions took place across the planet. From the depths to the shallow seas, the entire world was bubbling with spontaneous experiments. Some of these reactions were fleeting and vanished in an instant. Others, however, produced something new: complex molecules capable of lasting longer, capable of resisting. They were the first building blocks of biology, the invisible bricks of life. Among these molecules, amino acids, sugars, lipids, and nucleotides began to form. None of them were alive, yet all were necessary for life to exist. They accumulated in shallow pools, volcanic shores, and warm lakes. When the heat increased, the water evaporated, concentrating these substances even more. When the rains returned, they mixed again. This cycle of drying and dilution, repeated millions of times, helped the molecules join into increasingly longer chains. Small chemical structures, united by chance, began to form polymers, stable chains capable of storing energy and even replicating in a rudimentary way. The boundary between the inanimate and the living began to dissolve. The hydrothermal vents in the depths of the seas played an essential role in this process. There, the heat from Earth's interior met the cold ocean water, creating gradients of temperature and energy. These environments, rich in minerals such as iron, nickel, and sulfur, acted as natural catalysts, accelerating chemical reactions. Simple organic molecules brought by the water adhered to the mineral walls of these fissures, where they were heated, reorganized, and transformed. The interiors of these rocky formations were like microscopic factories. Within their pores, chemistry began to acquire rhythm, pattern, and persistence. Chaos was beginning to turn into organization. Sunlight also played its part. Intense and constant ultraviolet radiation broke apart the most fragile molecules, yet it also forced others to recombine into more resilient structures. This simultaneous process of destruction and creation was essential for natural chemical selection. Only the most stable molecules survived the heat and light, accumulating over time. Earth, unknowingly, was testing formulas. The ocean was its laboratory, and time, its scientist. Each molecule was a trial, each reaction an experiment, and over millions of years chance began to turn into direction. The combinations started to follow repeating patterns, as if matter itself were trying to remember something it had never learned. The edges of shallow lakes and the surfaces of minerals, especially clay, became ideal sites for these reactions. Clay, with its layered structure, could trap organic molecules and keep them close, allowing them to bond with one another. These surfaces acted as natural molds, organizing molecular chaos. Under conditions of heat and humidity, chains of amino acids began to link together, forming short peptides. Small vesicles of lipids, resembling microscopic bubbles, formed spontaneously, trapping water and compounds within them. These bubbles were fragile, yet they represented something unprecedented: boundaries. For the first time, there was something that separated the inside from the outside. The concept of the cell was beginning to emerge, still unconscious, still nameless. The planet, now calm, had become the perfect cradle for persistence. Chemistry did not rest. Each new cycle of rain, each eruption, each bolt of lightning was a spark for further transformation. Molecules that resisted harsh conditions became more common. Those that reacted faster multiplied. Nature, without intention, was creating patterns that resembled learning. The primordial soup was both chaos and memory. Within it, Earth stored the potential for life before life existed. It was as if the planet itself were dreaming, rehearsing forms of organization, testing sequences and reactions, waiting only for the moment when one of these combinations would become capable of copying itself. Fire had given Earth its body. Water had given it its soul. Now, chemistry was giving it movement. For the first time, the universe was creating complexity from simplicity. And amid this bubbling broth, a special molecule began to emerge, a structure capable of duplicating itself, changing and enduring. RNA, the molecule of information, would be born from these waters and would change the destiny of the planet. From it, the inanimate would become alive. But before that could happen, Earth still needed to take a deep breath, to stabilize and prepare the stage. The next step would not be merely chemical, it would be biological. And from that step, the eternal silence of the universe would be broken by the first breath of life. In the depths of the primordial seas, where sunlight never reached, the planet's heat met the cold water in a powerful contrast. The cracks in the ocean floor released jets of vapor and minerals, forming glowing columns of pure energy. These were the hydrothermal vents, true gateways between Earth's interior and its surface. From these underwater abysses, the planet exhaled its heat, its metals, and its gases, creating a unique environment filled with chemical reactions, electricity, and motion. It was the meeting point between fire and water, between hell and balance, between chaos and harmony. And it was there, in this world of darkness and heat, that life began to take shape. These vents released compounds rich in sulfur, iron, hydrogen, and methane. When these elements reacted with seawater, they created energy gradients, small chemical and thermal differences that acted as invisible engines. In these transition zones, inert matter began to behave in unexpected ways. The molecules formed in the primordial soup, carried by ocean currents, found in the mineral walls of these vents the perfect environment to react and organize. The porous structure of the rocks acted as a natural mold, trapping organic molecules and allowing them to combine repeatedly. It was Earth's first laboratory, a laboratory without scientists, but with the exact conditions for creation. The heat was intense, but not destructive. The temperature varied just enough to allow controlled instability in chemical reactions. Every crack, every gas bubble, every metallic particle served as a microscopic reactor. There, amino acids joined, lipids formed membranes, and nucleotides began aligning into chains. The environment was so active that within a few hours, the chemical composition of a small area could change completely. Yet some compounds survived. The most resistant, the most stable, those that could harness the available energy. Earth was filtering, selecting, experimenting. The laws of physics and chemistry played the role of evolution before biology existed. Scientists call this process chemical evolution. Before any cell came to life, matter itself was learning to react in increasingly efficient ways. The metallic minerals of the hydrothermal vents, especially iron and nickel sulfides, catalyzed these reactions, helping to transform simple compounds into more complex molecules. Nature, without intention, was replicating what humans would much later call biochemistry. Deep within the volcanic fissures, where pressure was immense and temperature shifted every second, the first architecture of life was beginning to emerge. Matter had no consciousness, but it already had direction. As time passed, these small chemical structures began to encapsulate themselves. Lipid vesicles, tiny bubbles that formed boundaries, emerged spontaneously, isolating groups of molecules from the surrounding environment. Inside these microchambers, chemistry became more concentrated and efficient. For the first time, there was something resembling an inside and an outside. This simple separation was one of the most decisive steps in the entire history of the universe. Within these fragile borders, chemical reactions began to repeat and eventually to sustain themselves. Chance was turning into pattern, pattern into persistence, and persistence into life. These primitive bubbles floated through the warm currents, near sources of heat. Some burst quickly, others lasted longer. Those that endured accumulated new molecules, some capable of storing and transmitting information. Among these structures, one would stand out. A molecule capable of copying itself, adapting and evolving. RNA would be the first step of biology. But before it, there was the world of pure reactions, a world where fire and water competed and cooperated at once. The planet was its own alchemist. The ocean was the crucible, heat was the fire, and matter was the dream. The result would be the beginning of the story of everything that would breathe, walk, and think. The hydrothermal vents were Earth's womb. In the contrast between hot and cold, between metal and water, arose the conditions that made life possible. No other known environment offered such variety of energy, molecules, and stability. Every reaction that occurred there was an attempt by the universe to create something that could persist. And one day, after billions of attempts, persistence triumphed over chance. A molecule learned to copy itself. A droplet learned to divide. And without witnesses, the miracle happened. Chemistry became biology, time became inheritance, and Earth, for the first time, was no longer alone. That transition, silent and invisible, would change the planet's destiny forever. The ocean currents continued to flow, the vents continued to exhale heat, and the molecules continued to dance. The surface of Earth, now stable and moist, began to reflect sunlight in shades of blue. The world had been transformed. The fire that once destroyed now sustained. The water that once extinguished now generated. Life, in its simplest forms, was born from the planet's own depths. And in the darkness where fire and water met, the universe whispered for the first time, "Now, live." In the warm depths of Earth, where heat and water met in perfect harmony, something extraordinary began to happen. Matter, once reacting at random, started to behave differently. Some molecules, formed in mineral waters and volcanic fissures, began to join in patterns that seemed to have logic. Small chemical chains, called nucleotides, started linking together, forming structures capable of storing information. These molecules were not alive, but they did something unprecedented. They remembered. They kept a record of the reactions that had occurred and repeated them almost automatically. It was the first glimpse of organization. Matter was beginning to imitate memory. Among these molecules, one in particular emerged, RNA, a delicate strand made of simple yet powerful chemical units. RNA was a sequence of building blocks that could bind to each other and, astonishingly, make copies of itself. This ability, to replicate, was the turning point between the inanimate and the living. With each replication, tiny imperfections appeared, and those imperfections created variation. Some of the copies were more stable, more resistant to heat and radiation, and therefore lasted longer. Others disappeared quickly. This process, repetition, variation, and persistence, is what, billions of years later, would be called evolution. Life was beginning, not as a being, but as a behavior. These RNA molecules floated through the warm seas, protected by small lipid vesicles that formed spontaneously. Each bubble was a miniature world, a tiny chemical universe isolated from the rest of the ocean. Inside them, RNA interacted with amino acids and minerals, triggering chain reactions. Some of these vesicles managed to grow, divide, and incorporate more molecules from their surroundings. For the first time, there existed something that multiplied. The planet, once made only of rock, fire, and water, now harbored small systems capable of replicating, evolving, and competing for energy. Earth had ceased to be merely a physical world. It had become a biological one. Molecular organization was pure cosmic harmony. Chemical reactions, once chaotic, began to follow complex patterns. RNA, folding upon itself, acquired shapes that made it more functional. Some of these shapes allowed it to catalyze new reactions, helping to produce even more molecules. It was at once both mold and tool, builder and plan. This duality made RNA something special, almost magical. It was as if matter had learned to think, even unconsciously. Each successful molecule carried within itself the legacy of the universe, the quest for balance and persistence. Life, at its core, was the continuation of physics, chemistry in motion that had decided to endure. Over time, RNA began to associate with other molecules that increased its efficiency. Small chains of amino acids, the first peptides, started to bind around it, protecting it and helping it maintain its shape. This alliance between information and structure would become the embryo of what billions of years later would evolve into DNA and proteins. Biology, still without a name, had already begun to write its own rules, and all of them emerged from the same cosmic equation: heat, energy, molecules, and time. Chance was no longer random, it was creative, and with each new replication, the planet learned something new about itself. These first molecules lived in a world in constant flux. The temperature of the waters changed, the pH fluctuated, volcanoes released gases that altered the composition of the seas. With each transformation, only the most adaptable molecules survived. The environment selected, even without intention. Nature was testing possibilities, refining combinations, perfecting structures. The most stable RNA endured, while the fragile disappeared. This process, repeated trillions of times, created a network of chemical reactions that became increasingly complex, interconnected, and persistent. Life was not born in an instant. It was sculpted by time, in silence, within the warm waters of a patient planet. The first self-replicating systems turned the ocean into a vast living network. No organisms existed yet, but life was already pulsing on a molecular scale. The ocean had become aware of itself, in a chemical sense. From that moment on, evolution was inevitable. The molecules that learned to store energy would survive the changes. Those capable of repairing their own damage would grow more complex. And over millions of years, the first simple cells would appear, small living bubbles capable of growing, dividing, and changing the world forever. The magic of molecules was not supernatural. It was physics in its most beautiful state, energy organizing itself into form, chaos transforming into pattern. The universe, which had begun in an instant of explosion and fire, was now experiencing a different kind of creation. The creation that grows, adapts, and learns. Chemistry had crossed the invisible boundary between being and existing. And at that moment, somewhere within the ancient seas, Earth became alive. The silence of the planet was broken, and the cosmos, for the first time, heard a new sound, the whisper of life beginning to breathe. Among all the infinite chemical combinations simmering in the primordial seas, one would change the destiny of the planet forever. It was a fragile molecule, made of sugars, phosphates, and nitrogenous bases, yet endowed with an unusual property, the ability to duplicate itself. This compound was rnakites, ribonucleic acid, a delicate yet ingenious strand that carried within itself the code of repetition. It did not merely exist, it remembered. Each sequence that managed to copy itself became an echo of its own pattern, perpetuating chemical information through time. For the first time in the history of the universe, matter had learned to reproduce its own form, and with that, the boundary between the inanimate and the living ceased to exist. RNA was the first self-replicating system on Earth. Unlike other molecules, it did not rely on chance to reform. It did the work itself. Under the right conditions, moderate heat, catalytic minerals, and abundant energy, this chemical strand could align free nucleotides in the water, creating copies of itself. Some copies were imperfect, and within those imperfections lay the secret of life. The errors, the variations, the small flaws in replication created diversity. Some of these new versions were more resistant to heat, others more efficient at attracting complementary molecules. The planet, unknowingly, had invented the first evolutionary process. Life was not born perfect, it was born persistent. These RNA molecules accumulated in energy-rich environments, such as hydrothermal vents and volcanic shores. There, constant heat and mineral flows favored chemical reactions. Each RNA copy that managed to remain intact for longer had a higher chance of producing descendants. The more stable strands folded upon themselves, forming three-dimensional structures that protected them from decomposition. These folds, known as secondary structures, also allowed RNA to catalyze other chemical reactions, acting as a primitive enzyme. It did not just copy itself, it created. It was the first being capable of using the environment to its advantage, manipulating energy and matter to continue existing. Over time, some RNA molecules began to interact with one another, forming networks of chemical cooperation. One strand helped assemble another, and together they produced complementary molecules that strengthened the cycle. This spontaneous collaboration increased reaction efficiency and reduced errors. It was as if matter itself began to understand the value of partnership. These molecular communities were the first ecosystems on Earth, systems of information, energy, and persistence that fed on the very flow of chemistry. The ocean was no longer a passive environment. It had become the stage for a ceaseless molecular dance, where every reaction was a step on the path to complexity. Modern science would call this period the FAOS, RNA world, an era when life was nothing more than a strand of information floating in the planet's waters. There were no cells, no membranes, no visible organisms yet, but there was already inheritance, mutation, and adaptation. RNA was at once the gene and the enzyme, the messenger and the builder. It was the architect of itself. This versatility explains why, to this day, RNA remains essential to life, present in every cell, every virus, every organism on Earth. It was the first language the planet ever learned to speak, a chemical language, universal, silent, yet infinitely persistent. As millions of years passed, RNA molecules began to seek protection. Some took shelter inside lipid vesicles, small bubbles that formed spontaneously, in waters rich in fats and minerals. Inside these bubbles, RNA was isolated from the harsh environment and could replicate more steadily. This was the embryo of the first cell. Sheltered, RNA began to coordinate chemical reactions inside its new home, controlling the flow of energy and the entry of molecules. The inert had become functional. The silent planet had just created the first biological system. Earth was breathing, even if it did not yet know it. The primordial oceans thus became the cradle of multiplication. Billions of RNA strands copied, competed, and evolved under the heat of volcanoes and the filtered light of the sun. The entire planet pulsed to a new rhythm, the rhythm of biology. The same laws that had created stars were now creating cells. Life did not arise by chance, but as a natural consequence of a universe that seeks complexity. And at the heart of this process, RNA remained the first testimony of order born from chaos. RNA was the first mirror of Earth. It reflected the planet's impulse to persist, to transform, to replicate. It was the chemical expression of the instinct that billions of years later would make a species lift its eyes and ask where it came from. Everything began there, in the warm waters of a silent world, with a molecule that learned to copy itself, a thread of information that defied oblivion. And that is why even today, in every human cell, RNA continues to repeat the same ancient melody, the primordial song that has echoed since the beginning of time, whispering, "I endure, I remember, I exist." Not all scientists believe that life was born in the hot depths of the ocean. Some suggest it may have emerged in a different setting, less hostile, yet equally mysterious. a place where time and patience replaced heat and pressure. Perhaps, they say, life began in shallow lakes, under the diffuse glow of the sun, along mineral-rich, clay-filled shores. Or, even more surprisingly, perhaps it was born in the cold, within layers of ice that preserved fragile molecules for millions of years. The birth of life, after all, may have had more than one cradle, and Earth, with its diversity of environments, offered all of them at once. The clay hypothesis is one of the most fascinating. It suggests that on the moist edges of ancient lakes and shallow seas, particles of clay may have acted as natural molds for organic molecules. These surfaces, filled with microscopic cavities, could have trapped amino acids, sugars, and nucleotides, allowing them to bind together in ordered sequences. Electrically charged, the clay would have acted as a catalyst, stimulating the chemical reactions necessary to form chains of primitive RNA and proteins. It was as if the planet, through its own mineral skin, was teaching matter how to organize itself. On these surfaces, chaos found structure. Earth was literally sculpting life with the hands of time. In some modern experiments, scientists have been able to reproduce this process. When organic molecules are deposited on clay layers and subjected to cycles of humidity and drying, they begin to join into long, complex chains. This shows that in the warm margins of ancient lakes, nature itself may have done the work of a laboratory. The day's heat evaporated the water, concentrating the compounds. The night's rain diluted them and restarted the cycle. Millions of times this process repeated, and at some point, one of those combinations found stability. One molecule that survived, one that replicated, one that learned. Life may have been born not from the depths, but from the surface, from the simple touch between mineral and organic. But there is also another hypothesis, that of Hausdis. On a young and unpredictable planet, not all regions were hot. As Earth cooled, large portions of its surface experienced periods of intense cold. Lakes and shallow seas froze at the surface while the water beneath remained liquid. This environment, protected from solar radiation and insulated from extreme heat, would have been the perfect place for the formation and preservation of delicate molecules like RNA. In the cold, chemical reactions occur more slowly, and precisely for that reason, they have more time to stabilize. Beneath the ice, chance found patience. The planet froze, but chemistry did not stop. These frozen surfaces may have acted as vast crystal laboratories. Organic molecules became trapped within the tiny fissures of the ice, aligned and protected from sudden temperature fluctuations. There, they could combine slowly, in a calm and silent rhythm. Some theories suggest that the first RNA may have arisen precisely in these cold environments, where the balance between stability and energy allowed the formation of more complex structures. In that case, life would have been born not from heat, but from serenity, not from fire, but from frost. The planet, ever dual, offered both the forge and the cradle, and in both matter found a path to persistence. There are also those who believe that life did not begin on Earth at all, but arrived here from another world. This hypothesis, called panspermia, proposes that microorganisms or simple organic molecules may have traveled through space, protected inside comets and meteorites, and survived their impact with the planet. If this is true, terrestrial life would have cosmic roots, daughters of distant stars and worlds. Experiments have shown that some bacteria and molecules can survive for long periods in the vacuum of space, enduring radiation and extreme cold. Thus, it is possible to imagine that the entire universe is a living network, exchanging microscopic seeds of life among worlds. In that view, Earth would be only one of the gardens where those seeds bloomed. Whatever the true cradle, the heat of magma, the touch of clay, the shelter of ice, or the breath of the stars, the result was the same. Matter found form, form found pattern, and pattern found permanence. Life was born because the universe wished to remember, and Earth, in its balance between fire and cold, was the perfect place for that memory to manifest. These hypotheses do not exclude one another, they complement each other. Perhaps all are true. Perhaps life had many beginnings, tiny sparks arising in different places, some vanishing, others persisting until they met and merged in the same ocean. Earth was vast enough to host all attempts, and patient enough to wait for one to succeed. What matters is not where life began, but that it began, because from that moment on, the planet would never be the same. For billions of years, Earth prepared the stage. Fire, ice, storms, and warm seas created the perfect alchemy. And then, in a silent and invisible instant, the improbable happened. In the mineral-rich, tepid waters, tiny structures formed from organic molecules began to behave in an entirely new way. They were simple, fragile, and microscopic, yet they did something no rock, no volcano, no lightning had ever done before. They changed. They grew, absorbed matter around them, and sometimes divided. These structures are now known as protocells, the ancestors of living cells. They were only bubbles of lipids and RNA, but within them something completely new was taking place. For the first time, the universe was experimenting with what it meant to be alive. These protocells were tiny spheres, thousands of times smaller in diameter than a grain of sand. Their membranes were made of fatty molecules that spontaneously organized themselves in water, forming flexible and permeable boundaries. Inside them, RNA, that delicate thread of chemical information, carried out reactions, stored energy, and tried to copy itself. Some protocells grew by absorbing molecules from their surroundings. Others fused together, exchanging compounds and information. And when they grew unstable in size, many divided, giving rise to new spheres. It was a primitive but essential process. Cell division had begun. The planet, silent and damp, watched the first biological reproduction in history. Inside these protocells, chemical chaos began to gain direction. RNA catalyzed reactions, helped produce small proteins, and gradually chemistry became functional. Molecules started to cooperate, forming interdependent systems. One reaction gave birth to another and another and another. A self-sustaining cycle. This was the birth of metabolization, the first step toward true biological behavior. For the first time, something in the universe was feeding on energy and transforming it into motion, into persistence, into existence. Life ceased to be merely a spontaneous reaction. It became a continuous process. These protocells floated in shallow waters, near heat sources or volcanic lakeshores. They multiplied by the millions, competing for space and chemical resources. Some survived longer, adapting better to changes in temperature and acidity. Others disintegrated quickly, releasing their components back into the ocean. Natural selection, even on a molecular scale, had already begun. Chance was turning into logic. Nature, without awareness, was beginning to reward efficiency. With each new generation of protocells, the planet became a little more alive, a little more organized, a little more aware of its own potential. Over time, these structures began to incorporate new mechanisms. Some protocells learned to use simple proteins to stabilize their membranes. Others began storing energy in special molecules similar to what we now call adenosine triphosphate, the universal currency of life. This ability to capture and preserve energy was what allowed protocells to survive longer and respond to their environment more efficiently. RNA, in turn, began to evolve into something even more sophisticated. DNA, a more stable, longer-lasting molecule capable of storing vast amounts of information. The transition from RNA to DNA was the first great evolutionary leap of life, the moment when biology gained permanent memory. At that point, the primordial ocean was already a soup of potential organisms. Billions of protocells formed, broke apart, and reformed in a constant cycle. Some grouped together, forming rudimentary colonies, while others remained isolated. It was a molecular ecosystem in full emergence. The planet, once a desert of fire, was now breathing. The air, once toxic, began to transform, and the presence of life, still invisible, slowly altered the chemistry of the atmosphere and the seas. Each protocell that was born was a tiny spark of cosmic awareness, a manifestation of the universe's ability to organize and recognize itself. The most remarkable thing is that this process was not intentional. No conscious force planned the emergence of life. It was nature itself, in its search for balance and continuity, that found this path. Fire provided energy, water offered stability, carbon brought structure, and time did the rest. Life did not arise by chance. It was an inevitable consequence of the laws of physics and chemistry. Earth was the only place, among billions of worlds, where all the conditions aligned. And when that happened, the universe ceased to be a mere observer. It became a participant. Those first protocells, fragile and anonymous, are the ancestors of everything that would come after. Every tree, every fish, every human being carries within itself the same impulse that once moved them, the desire to continue, to persist, to exist. It all began there, in the warm waters of a newborn planet, with microscopic bubbles that learned to divide. Life in its purest form is the echo of that first instant. After billions of years of silence, the universe had finally learned to breathe. After countless cycles of attempts, failures, and repetitions, RNA, tired of reinventing itself, created something that would change everything, a way to preserve. This new structure, more stable, more precise, and longer lasting, would be DNI, deoxyribonucleic acid, the spiral of life, the library of time. DNA was born as an improvement, a natural refinement of what RNA had begun. While RNA was fragile and temporary, DNA could withstand heat, radiation, and the chaos of the primitive environment. It did not merely store information about how life should be. It stored how life should continue to be. It was the birth of inheritance, the ability of life to remember itself. This extraordinary molecule was composed of two intertwined strands, bound together like a spiral staircase extending infinitely. Each step of that staircase was made of paired chemical bases, adenine, thymine, cytosine, and guanine, that fit together like pieces of a cosmic code. The simplicity of its structure concealed an immeasurable power. Within its sequences, DNA could store all the instructions necessary to build and maintain a living being. For the first time, life no longer depended solely on external conditions. It carried within itself the complete blueprint of its own existence. Memory, once scattered across the seas, was now concentrated within every cell, every molecule. The planet had learned to write. DNA completely transformed the course of evolution. Now each protocell that possessed it could copy its information more accurately and pass it on. The errors that once destroyed fragile RNA molecules became rare, yet they still occurred, and it was precisely those small mistakes that allowed change, adaptation, and progress. The perfect balance between stability and mutation had been achieved. Earth, with its warm waters and volcanic springs, had become a living school of biology. Life had invented genetics, and with it, the future. With DNA came the first true living cells. Unlike the fragile, simple protocells before them, these new forms possess stronger membranes, internal energy systems, and organized mechanisms of replication. They were unicellular beings, microscopic yet fully biological. Inside each cell, DNA was protected within a gelatinous matrix, the cytoplasm, while RNA, now transformed into a messenger, read its instructions and coordinated the production of the first proteins. It was a perfect symbiosis. DNA stored the knowledge, and RNA put it into practice. The planet had created the first functional language. Life spoke, and the world listened. These first cells multiplied slowly, feeding on organic compounds dissolved in the oceans. They were simple yet ingenious organisms. Some learned to use the chemical energy from hydrothermal vents, while others began to absorb light, initiating the process that would much later become photosynthesis. The planet, once illuminated only by fire and lightning, was now beginning to generate its own inner light, a light made of living energy. Each cell, each copy of DNA, was a fragment of that new flame. Earth, which had once held seas of magma, now held seas of life. DNA brought to life something no chemical reaction had ever achieved: continuity. Before it, everything emerged and vanished in the same instant. Now, time began to have meaning. What one cell learned could be passed on. Life became an unbroken conversation between the past and the future. With every cell division, information was duplicated, transported, shared. Biological inheritance had been born, and with it, the concept of lineage. Life, for the first time, left traces that would endure through ages, ice, extinctions, and rebirths. Everything that would come after, forests, oceans, dinosaurs, humans, would be only a long reading of that same story, begun by a single molecule. Meanwhile, the planet continued to change. Tectonic plates shaped continents, volcanoes released new gases, and the atmosphere slowly transformed. But now, something made a difference. Earth had gained internal agents of change. Cells began to interact with their environment, consuming and releasing substances, altering the composition of air and sea. Biology began to shape geology. The planet ceased to be just a stage and became a character. Life and Earth, inseparable, became one. A vast organism pulsing in all directions, breathing through waves and wind. DNA was more than a molecule. It was the first mirror of the cosmos. In it, the universe recorded its own desire to keep existing. Every living being, from bacteria to humans, is a chapter in that record, written with the same 4 chemical letters. Every heartbeat, every growing leaf, every dividing cell is a reading of that ancient text, a recitation of the Earth's primordial memory. Life, at last, had become eternal, not because it does not die, but because it remembers. DNA is the memory of fire, of water, of chemistry, and of time. It is the planet's silent voice, whispering for billions of years, "I am still here." For billions of years, life existed without ever seeing the sun. It fed on the heat from within the Earth, on the chemical reactions bubbling in hydrothermal vents, and on the nutrients dissolved in the primordial oceans. But all of that would change when some of these cells began to perceive the world differently, not with eyes but with molecules. They discovered that light was not merely something that illuminated, but an endless source of energy. Thus, photosynthesis was born, the process that would transform life and the planet forever. It was the moment when sunlight ceased to be a distant spectacle and became nourishment. For the first time, Earth began to breathe in rhythm with the cosmos. The earliest forms of photosynthesis looked nothing like the plants of today. They were performed by simple microorganisms known as cyanobacteria, tiny unicellular beings that drifted through the planet's warm oceans. These bacteria developed light-sensitive pigments, the precursors of chlorophyll, which captured solar energy and used it to transform simple molecules such as carbon dioxide and water into sugars. It was perfect alchemy, turning light into life. In the process, they released a byproduct that would change everything: oxygen. At first, this gas was merely a chemical consequence, but over time, it would become the essential breath of all biology to come. For millions of years, the oxygen released by cyanobacteria immediately reacted with the iron dissolved in the oceans, forming oxides that settled on the seafloor. These sediments, called banded iron formations, are the mineral scars of that period. Each layer of these rocks is the record of a pulse in the planet's respiration. With every generation of cyanobacteria, more oxidized iron accumulated, and little by little, the oceans became clearer and bluer. When the iron was finally depleted, oxygen began to escape into the atmosphere. What had once been an invisible trace became a dominant component. The air, once toxic and suffocating, began to change. Earth was manufacturing its own future. This monumental event became known as the Great Oxidation, and it marked the first major biological revolution of the planet. The atmosphere, which for billions of years had been composed of methane, ammonia, and carbon dioxide, began to fill with oxygen. This gas, poisonous to many life forms of the time, killed countless ancient species, forcing evolution to carve new paths. Yet, at the same time, it opened the door to something far greater. Oxygen allowed energy to be used more efficiently within cells. It was the spark that made respiration, complex organisms, and eventually consciousness possible. The light of the sun had ignited the engine of life. Cyanobacteria formed colonies that floated like luminous carpets across the surface of the seas. Over time, these clusters began to secrete layers of minerals and organic matter, creating rocky structures known as stromatolites, the oldest living fossils on Earth. In many places on the planet, they still exist, breathing silently under the light, as witnesses of an era when the entire world was a greenish-blue ocean. Each layer of these stromatolites is a signature of persistence. Day after day, for millions of years, cyanobacteria continued their work, producing oxygen and shaping the air we breathe today. Life had become a planetary architect. With the growing presence of oxygen, the sky began to change color. The sun's ultraviolet radiation, once deadly, started interacting with atmospheric oxygen, forming a new protective layer: ozone. This invisible film enveloped the planet, blocking the most destructive radiation and making the surface safer. It was as if Earth had created its own skin. For the first time, sunlight could touch the ground without causing destruction. The nights became darker, and the days brighter. The sky took on the deep blue hue we know today. The atmosphere was finally stabilizing. The planet breathed in rhythm with the sun. The impact of photosynthesis was profound and irreversible. It not only transformed the atmosphere, but also altered the climate and the composition of the oceans. The rise of oxygen reduced the greenhouse effect, cooling the planet and triggering what would become one of Earth's first ice ages. Life, which had created its own energy, now faced the challenge of surviving the consequences of its success. Many species disappeared, but those that endured learned to use oxygen in a new way, to release energy from food. Cellular respiration was born. Life had learned to breathe and with that to evolve. The planet, once ruled by chemistry and chance, now pulsed with intention. Light had taught matter a new rhythm. Day and night became vital cycles, and the sun began to command Earth's time. Each sunrise was an invitation to photosynthesis, and each sunset a reminder that life depended on balance. Air, oceans, rocks, and beings were now connected in a single breath. The universe, which had begun in absolute silence, now vibrated with the invisible sound of photosynthesis, the sound of light transformed into life. Oxygen, the gas that now sustains all life on Earth, was not always a symbol of balance and abundance. When it began to accumulate in the atmosphere around 2.5 billion years ago, it became the agent of the first great biological catastrophe in history. The planet, which had once breathed methane and volcanic gases, started filling with a new element, highly reactive, corrosive, and deadly to most forms of life of that era. The same gas that would one day give rise to respiration and the flourishing of future species was at first a poison. Earth was about to endure its first natural genocide, an invisible collapse caused not by fire, but by air. For billions of years, life had thrived under an atmosphere devoid of oxygen. The first microorganisms, known as anaerobes, had evolved to live in reducing environments where methane and hydrogen were the main sources of energy. For these beings, oxygen was a chemical disaster. When it began to accumulate in the oceans and the air, it reacted violently with organic and metallic compounds, destroying the cells that lacked defenses against its toxicity. Cell membranes oxidized, enzymes disintegrated, and the once fertile oceans became deadly. The gas of life was, in that moment, the gas of death. This event became known as the Great Oxidation, and it marked the planet's first global ecological collapse. As cyanobacteria continued to produce oxygen, the atmosphere transformed rapidly. Methane, which had once kept the planet warm, was oxidized into carbon dioxide, a weaker greenhouse gas. With the loss of atmospheric heat, the global climate began to cool. The oceans, saturated with iron and oxygen, turned acidic, and the chemical equilibrium that had sustained early life fell apart. Earth plunged into an icy age, and the vibrant blue of the seas gave way to a dull, cold gray. It was the price of breath. Most anaerobic life forms vanished. Those that survived retreated into the depths where sunlight could not reach and oxygen remained scarce. There, in the shadowed oceans, they continued to exist in isolation, preserving an ancient way of life, almost fossilized in time. Some of these lineages still exist today, hidden within deep-sea vents and mineral caves, as biological relics of a world before air. Meanwhile, on the surface, a new kind of life began to rise. Organisms that learned to use oxygen instead of fearing it. They discovered that this gas, so lethal to others, could be the most efficient way to generate energy. The evolutionary tragedy became opportunity. Aerobic respiration was nature's answer to collapse. Unlike the ancient anaerobic processes, it allowed living beings to extract far more energy from food molecules by using oxygen as a catalyst. This biochemical change would become the greatest evolutionary leap in Earth's history. Cells that mastered this technique could grow faster, divide more efficiently, and endure environmental variations with greater resilience. Extinction, which seemed to mark an ending, was in truth the beginning of a new era. Once again, the planet taught that every destruction carries within it the seed of renewal. Meanwhile, the rise of atmospheric oxygen brought profound physical consequences. The upper layers of the air began to react with solar radiation, forming ozone, the protective shield that would one day allow life to migrate to the surface. At the same time, global cooling intensified, driving the planet into one of the most severe ice ages in its history. This snowball Earth covered continents and oceans with ice, turning the world into a white mirror. It was a period of planetary dormancy in which only the most adaptable beings survived. Life, compressed and silent, persisted hidden beneath the ice and around hydrothermal vents. But the cold also brought stability. When the glaciers finally receded, the planet emerged transformed. The atmosphere was clear, the sky blue, and the oceans rich in oxygen and nutrients. The tragedy had purified the Earth. The air had become breathable, and the climate more temperate. The survivors of the collapse, organisms that used oxygen, came to dominate the planet, ushering in a new biological era. From them would arise all complex forms of life that would ever exist thereafter. The death of the old had given rise to the multiplication of the new. The Great Oxidation was, paradoxically, the greatest act of creation in history. It revealed that life is, above all, transformation, that destruction is part of the process of perfection. Oxygen, the same gas that nearly extinguished existence, became the fuel of the future. From that moment on, Earth began to pulse to a new rhythm, the rhythm of energy, respiration, and awareness. The planet had not merely survived its own revolution, it had been reborn. And beneath the new blue sky, the cells that had learned to use oxygen looked upon a different world, colder, clearer, more promising. For the first time, life breathed the same air we breathe today. For the first time, the planet knew what it meant to live with purpose. After the Great Oxidation, Earth's atmosphere had changed forever. Methane, which had once warmed the planet like an invisible blanket, was destroyed by the newly released oxygen. The result was devastating. Heat began to escape into space, and the thermal balance that had kept the oceans liquid was broken. Little by little, temperatures plummeted. Sunlight reflected off the new white clouds of frozen vapor, further intensifying the cooling. It was the beginning of the most severe glacial age in history, a time when Earth from pole to pole was covered by a mantle of ice several kilometers thick. The blue planet had become a white world. Life, still fragile and microscopic, was facing its first apocalypse. The oceans began to freeze from the outside in. Thick surface layers of ice sealed off the deep waters, where a few forms of life could still survive. The surface turned into a frozen desert. No open seas, no rain, no wind. Even sound seemed to die. The volcanoes, once relentless, now roared beneath the weight of ice, struggling to pierce the hardened crust and release trapped gases and steam. The planet was silent, as if it had stopped breathing. It was a long white night that would last millions of years. Global temperatures dropped to extreme levels, and the bright blue of the sky faded into a cold, milky twilight. Earth was sleeping beneath the ice. Scientists call this period Snowball Earth. Evidence of this catastrophe lies in rock layers found on every continent, glacial deposits dating back more than 700 million years. They show that ice reached regions near the equator. It was as if the planet had been plunged into a cosmic freezer. Yet beneath this deadly shell of ice, life found unlikely refuges. In the ocean depths, around hydrothermal vents, colonies of microorganisms continued to survive by feeding on chemical energy. In those dark fissures where light never reached, life kept its flame alive. It was a silent resistance, but enough to ensure the planet would not become an eternal tomb. Meanwhile, the volcanoes kept working. Slowly, they injected carbon dioxide into the atmosphere, and with the oceans frozen, this gas could no longer be absorbed. Over millennia, the buildup of this greenhouse gas began to shift the balance again. Earth, imprisoned beneath the ice, started to warm from within. The heat from the planet's interior, combined with the gradual rise of carbon dioxide, initiated a slow and steady thaw. As the ice melted, it revealed dark rock surfaces that absorbed more sunlight, accelerating the process. The cycle reversed itself. The same light reflection that had sealed the planet now gave way to a spiral of warming. The white world was beginning to awaken. The thaw brought unimaginable storms. As the ice cracked, It released immense volumes of trapped water, flooding continents and carving new valleys. The oceans, enriched with minerals and sediments from the melt, became a fertile soup for the biological explosion to come. Life, which had survived in the deep and in the dark, now emerged stronger, adapted, resilient. Ancient cyanobacteria bloomed again, painting the seas green and restoring the balance of oxygen. The planet, which had known frozen death, was reborn as a living body. Earth had survived its own blackout. This rebirth marked the end of stagnation and the beginning of a new evolutionary phase. The extreme cold had selected only the most resilient organisms, those most efficient in using energy and storing nutrients. When warmth returned, these lineages would dominate the planet, giving rise to the first multicellular organisms. The ice, once the enemy, had become the filter of perfection. Life had learned to endure the impossible. The planet, purified, became a cradle once more. Snowball Earth was more than a climatic event. It was a rite of passage. It showed that the planet and life share the same destiny. Both must die a little to be reborn. The glaciers that had erased the seas also prepared the stage for future diversity. Beneath the ice, the world was dreaming, and when it awoke, it was ready to begin again. When the ice began to retreat, Earth awakened like a colossal being rising slowly from a deep sleep. The melting of the ice caps released entire oceans trapped beneath the hardened crust, and the heat from the planet's interior, accumulated over millions of years, caused the surface to expand and crack. It was then that Earth's face began to change. From the depths of the sea, rocky masses rose, revealing the first of primordial continents. They were barren mountains, covered in volcanic ash and veiled in mist. For the first time since the planet's birth, there was solid ground, fragments of stone emerging on the aquatic horizon. The world, once flat and liquid, now had volume, texture, and relief. These new formations were the result of the endless dance of the tectonic plates. Beneath the weight of the oceans and the heat of magma, parts of the crust began to collide, fold, and sink, creating zones of subduction and uplift. The planet's internal energy slowly sculpted its surface. Each collision, each eruption, and each fissure opened in the deep released more material from Earth's incandescent core. The result was a mosaic of rocky islands that joined and separated in geological cycles lasting millions of years. These ancient blocks, known as cratons, are the foundations of the modern continents, the mineral roots that support the ground on which we stand today. The post-glacial climate was unstable. Rain was intense, winds were violent, and volcanic eruptions remained frequent. The newly formed rivers carved through young rocks, carrying minerals into the oceans and enriching marine chemistry. It was in this delicate balance between destruction and creation that life began to expand again. The shores of these continents became fertile zones where water, light, and nutrients converged. There, microorganisms gathered in colonies, forming biological mats that coated the rocks with a thin green layer. They were the first biocrusts, the living skin of the planet. The world, once purely mineral, began to pulse with life on its surface. Over millions of years, these rocky masses grew and stabilized. The primordial continents began to merge, forming superblocks that drifted slowly over the hot mantle. Earth became a dynamic organism, with currents of magma fueling the eternal cycle of creation. Each eruption brought new minerals to the surface. Each rainfall dissolved and redistributed these elements across the seas. This constant exchange between rock and ocean created the chemical foundations of future ecosystems. The solid crust and the liquid oceans now formed a stable partnership, the body and the blood of the planet. These first continents were nothing like the ones we know today. There were no trees, no soil, no visible life, only vast plains of stone and lava, with acidic rivers streaming over their surfaces. The air was still heavy with carbon dioxide and sulfur, and the horizon was dominated by active volcanoes. Yet this hostile landscape marked the beginning of something grand. The exposed rocks began to react with atmospheric oxygen, triggering chemical weathering, a slow erosion that would help regulate Earth's climate for billions of years. The planet was learning to balance its own temperature. Geology and biology were beginning to speak to one another. Along the coasts, the meeting of land and sea formed natural pools where life flourished in new ways. There, Colonies of cyanobacteria, once free-floating, began to attach to rocks, creating visible structures. Stromatolites. These layered formations were microscopic cities. They breathed, expanded, and interacted with their surroundings. For the first time, Earth displayed a living landscape, a surface shaped not only by volcanoes and earthquakes, but also by organisms. Mineral crust and organic life intertwined, weaving together the tapestry of the modern world. The rise of the continents marked the beginning of the global interaction between solid Earth, ocean, and atmosphere. Tectonics, climate, and biology became gears in the same system. The planet ceased to be a theater of isolated reactions and began to function as an integrated network of equilibrium. Every mountain influenced the wind, every river shaped the sea, every organism altered the air. Earth had become a living system on a planetary scale. These first continents were the foundation upon which everything else would rise: forests, deserts, animals, civilizations. The solid ground that would sustain life was finally in place. From that moment onward, Earth would no longer be merely the planet of fire and water. It would become the planet of calm soil, of united structure, of enhanced stability. Rock had conquered chaos. The once liquid world had found its footing. For billions of years, Earth lived beneath a thick, suffocating mantle. The primitive atmosphere was a mixture of carbon dioxide, methane, ammonia, and volcanic dust, so dense that sunlight barely pierced it. The planet was submerged in a reddish twilight, wrapped in gases that warped the horizon and hid the stars. But as time passed, the fire calmed. Eruptions waned, the oceans stabilized, and life began to breathe the very air it had created. Cyanobacteria, silent and persistent, slowly turned chaos into clarity. The oxygen they released reacted with toxic gases, cleaning the atmosphere bit by bit. And then, at some forgotten point in time, the impossible happened. The sky turned blue. The air became lighter, clearer, more stable. For the first time, the sun's rays crossed the atmosphere without hitting a wall of ash and smoke. Light scattered, interacting with oxygen and nitrogen molecules, which filtered the colors and left only the vibrant blue reflected to our eyes. It was one of the most beautiful moments in the planet's history, the birth of day. The world, which had lived in shadows and red glints, saw the sun as a real star. Dawn, for the first time, was visible, and with it came something that changed everything: the rhythm of light. The planet began to pulse according to the cycle of day and night, but the blue sky was more than an aesthetic shift. It marked the start of climatic balance. Sunlight now reached the surface at a moderated intensity, warming the planet more evenly. Clouds formed and dissipated in stable cycles, and rains began to follow a pattern. The heat of day and the chill of night created air currents that distributed energy around the globe, feeding the wind cycle. For the first time, climate had order. Earth stopped being hostage to volcanic outbursts and became an organism breathing under the sun. This balance brought another vital element: the ozone layer. Formed by the interaction of oxygen with ultraviolet radiation, it became the planet's protective shield. Without this invisible film, the surface would have remained sterile, scorched by solar energy. With it, destructive light was filtered, allowing gentler radiation to reach the ground. Life, which had existed only in the oceans, could now approach the surface without being annihilated. The atmosphere became not only transparent, but protective, as if Earth, after millions of years of chaos, had finally learned to care for itself. As the air stabilized and the sky cleared, the planet's landscape changed completely. Seas that had been dark now reflected the blue of the firmament, turning into liquid mirrors that gleamed under the sun. Rocky, humid, silent islands took on golden edges at dawn. The horizon sharpened, and the daily cycle set a new biological time. The sun, once an invisible enemy hidden behind clouds, became the metronome of life. Every sunrise and sunset was a promise of continuity. The planet had gained the gift of light. The atmospheric transformation had deep consequences for Earth's chemistry. Free oxygen allowed the formation of new minerals, colored oxides and silicates that tinted rocks and sediments. The planet's very color changed. The surface, once ruled by gray and reddish tones, took on ochres, browns, and blues. Earth began to look like itself. The contrast between the blue sky and the green-blue oceans defined the world's visual identity. It was the birth of the planetary landscape, a spectacle of balance and beauty, unmatched by any other rock in the solar system. The clarity of the sky also allowed something previously impossible: time. With the sun visible, life began to measure its cycles and synchronize its functions. Day and night became natural clocks. Cyanobacteria produced energy by daylight and rested in darkness. This rudimentary behavior gave rise to the first unbiological rhythms, the embryo of what we now call the circadian clock. The planet, in its vastness, was learning to beat with regularity. The chaos of the past gave way to the cadence of harmony. The blue sky was a mirror of Earth's maturation. It did not appear suddenly, it was earned. Every molecule, every bacterium, every breath helped clear it. The light we see today is the echo of that ancient victory. The planet, once covered in fire and smoke, now shone under a gentle sun. Earth was no longer a boiling hell. It was a blue paradise floating in space, with a calm heart and its gaze set on the infinite. With the rise of the blue sky and the stabilization of sunlight, the planet gained something it had never had before: regularity. The chaos of volcanoes, the eternal storms, and the ages of darkness gave way to a predictable cadence. The sun rose, the sun set, and with each cycle the world renewed itself. This simple pattern, light and shadow, heat and cold, day and night, transformed life forever. Time, once indifferent, began to have meaning. Earth's rotation became the metronome of biology, and all forms of life, from the simplest to the most complex, learned to move in tune with that beat. For the first time, the planet breathed in rhythm. Cyanobacteria, which dominated the seas, were the first to react. They adjusted their metabolism to the presence and absence of light. During the day, they captured solar energy and produced oxygen. At night, they rested and stored energy. This cyclic behavior was the embryo of the unbiological clock, an internal mechanism that synchronizes vital processes with the planet's rotation. Over time, this adaptation spread across the biosphere. Light became the master signal, and darkness the necessary interval for recovery. Thus, Earth's cycle shaped the rhythm of life. Each dawn was a promise of continuity, each dusk a pause in the symphony of existence. The planet, once governed only by physical forces, was now guided by biological laws as well. The first ecosystems began to emerge. In shallow seas, colonies of microorganisms formed biological mats over rocks and sandy beds. These organisms created microenvironments where chemistry and biology intertwined. Nutrient exchange, carbon recycling, and oxygen release turned every centimeter of the ocean into a living web. It was the preview of what, billions of years later, would become the cycle of nature. Life had learned not just to survive on the planet, but to cooperate with it. These early biological communities were simple yet extraordinary. They created shadows that protected lower layers from radiation, produced substances that fed other organisms, and together stabilized their surroundings. It was a self-regulating system, a harmony between competition and balance. Where light was strongest, cyanobacteria flourished. In deeper regions, other microorganisms that did not depend on the sun prevailed. This natural division of niches was the birth of ecological diversity. The planet, once uniform, began to specialize. Each region, each depth, each temperature gave rise to a new kind of life. The alternation between the heat of day and the chill of night also triggered new physical phenomena. Ocean currents began to move more regularly, transporting nutrients and heat across the seas. This circulation connected distant ecosystems and allowed broader biological networks to form. Life was no longer confined to isolated pockets. It began to spread globally. Earth was becoming an interconnected system where the movement of a single molecule could influence the fate of a continent. The planet was no longer a collection of separate environments, but a planetary organism, pulsing in unison with the sun. As days and nights became more predictable, evolution accelerated. Life learned to anticipate time, to prepare for dawn and dusk. This anticipation gave rise to more complex behaviors, a primitive form of environmental awareness. Simply knowing when light would return or when cold would arrive became an evolutionary advantage. Nature began to think in time. And this thinking was not in a mind, but in every cell, in every organism, breathing in rhythm with the planet. Earth's clock was engraved in the biology of life itself. The first stable ecosystems profoundly altered the planet's chemistry. Gas exchanges between organisms and atmosphere balanced carbon dioxide and oxygen, keeping the climate mild and constant. The carbon and nitrogen cycles born in those primordial seas became the foundation of life to this day. The ocean had become a chemical lung, a living laboratory that breathed, and as the sun rose over the calm waters, Earth began to resemble the world we know. The alternation between day and night was no longer a physical phenomenon, it was the heartbeat of life. From that moment on, the planet's history would no longer be merely geological, it would become biological. Each rotation of Earth marked not only the passing of time, but the growth of complexity. The blue of the sky and the green of the seas became the backdrop for a choreography that would never end. The universe, once only silence and fire, now had cadence, the rhythm of Earth. As much as Earth may seem today like a blue, quiet paradise, it still carries on its body the scars of its violent youth. Every mountain, every volcano, every ancient rock is a fragment of the incandescent past that gave rise to everything. The ground beneath our feet is direct testimony to a time when the planet was fire and chaos. The deepest layers of the crust still preserve minerals formed at temperatures so high they could only exist in a world of magma. These minerals, zircons, olivines, pyroxenes, are the fossils of fire. Within them are atoms of oxygen, iron and silicon that have never again seen the light, silently keeping the memory of creation. Zircons, in particular, are Earth's oldest archives. Some date back more than 4 billion years, remnants of a newborn planet. These tiny gems, invisible to the naked eye, endured every geological era, withstanding pressure, heat, and extreme transformations. Locked within their crystalline structure are traces of the chemical makeup of the first oceans and the primitive atmosphere. They are the planet's mineral diaries, written even before life emerged. Each zircon is a word in the language of ancient Earth, and together they form a book that tells how hell became home. Volcanoes, in turn, are the surviving lungs of that time. Though now only a fraction of what they once were, they still repeat the young planet's gestures, spitting fire, gases, and ash that renew the geological cycle. Every eruption is a living reminder of the incandescent past, proof that the fury that shaped the world never completely vanished. Inside the planet, heat still circulates, moving tectonic plates and feeding Earth's molten heart. Beneath our feet, the same magma that once covered the globe still pulses, slow and steady, like the planet's blood. But the marks of hell are not only in the rocks, they are also in Sumus life. Every organism carries within itself chemical traces of its origin. The elements that compose us, carbon, iron, calcium, sulfur, were forged in stars long before the solar system was born, but they took on new forms in Earth's furnace. The iron in our blood is the same that once filled the red seas of the young Earth. The calcium in our bones came from minerals dissolved in the first rains. The carbon that sustains our cells is the direct air of the carbon dioxide that choked the air of the infant planet. We are, quite literally, descendants of fire. Even life's essential molecules still bear the signature of that extreme past. The enzymes that regulate our chemical reactions often work best at elevated temperatures, as if they still remembered the heat of hydrothermal vents. Certain modern bacteria, known as extremophiles, live in conditions very similar to those at Earth's beginning, in boiling waters, acidic environments, and crushing pressures. They are biological relics of a forgotten era. They did not evolve to tolerate heat. Heat is their natural state. By studying them, science glimpses the reflection of primordial life, the planet's first breath preserved in time. Mountain chains also hold traces of infernal ages. When we look at the Andes, the Himalaya, or the mountains of Canada, we see only icy, stable peaks, but their roots hide layers of rock that were once liquid. With every movement of the plates, the past is pushed upward, and fragments of the primitive crust emerge at the surface. These pieces of geological history reveal that nothing on Earth is truly new. Everything we see, the continents, the seas, the very air, is the result of billions of recyclings. The planet is an alchemist, turning the old into the new without ever forgetting where it came from. Even the oceans carry memories of hell. The saline composition of the water that sustains all marine life is the chemical echo of gases that escaped from primordial volcanoes. The chlorine and sodium dissolved in today's seas are direct descendants of reactions between magma and the vapor of the first storms. When we dive into the ocean, we touch the very environment that gave rise to life, only cooler, calmer, domesticated by time. Today's waves are distant echoes of tempests from 4 billion years ago. These marks, mineral, biological, and chemical, remind us that Earth has not forgotten what it was. Even transformed, it still carries the memory of fire. The planet is a survivor of its own birth, a wounded body that learned to bloom. In every rock, in every cell, there are vestiges of the original hell. Life and the planet coexist as two faces of the same story, one of destruction, the other of rebirth. Fire became blood, chaos became cycle, hell became home. Inside every living cell on the planet lies an invisible archive that carries the complete history of Earth. It is not written on paper nor carved in stone, but encoded in molecules, DNA, the oldest biological text in the known universe. When we look at it, we are not merely observing life, we are reading the past. In its sequences of chemical bases lie direct echoes of the heat of hydrothermal vents, the electric storms, and the molecular chaos that once ruled the primordial seas. Each gene is a chemical memory. Each copy of DNA is an inheritance of the fire that refused to die. The genetic code is universal. From the oldest bacteria to human beings, all forms of life share the same molecular language, made of the same 4 letters: adenine, thymine, cytosine, and guanine. This immutable alphabet has survived catastrophes, ice ages, and extinctions. It has crossed billions of years without ever losing meaning. It is the language of Earth, spoken in silence by all that lives. The fact that this language has remained unchanged since the first microorganisms proves that there is continuity between the inferno of origins and the paradise of today. Life never started over. It simply continued the same song, changing rhythm as the planet transformed. Within DNA, traces of a world ruled by heat and chaos are still preserved. Many genes that today perform simple functions, such as repairing damage, resisting radiation, or surviving acidity, are direct inheritances from a time when those conditions were daily reality. Modern cells still carry ancient mechanisms that protect them from extreme temperatures and toxic environments. These tools were never forgotten because, even calmer now, the planet remains unpredictable. Life learned to prepare for chaos. It is as if the cells remember the fire, keeping within themselves a survival map written by hell itself. Some enzymes also reveal this ancestral memory, the so-called thermophilic proteins. For instance, are modern versions of ancient molecules that evolved to endure extreme heat. They still exist in certain microorganisms, living in hydrothermal vents and undersea volcanoes. These enzymes function at temperatures that would kill almost all other life forms, as if destined to remain in the environment where they were born. When scientists study these molecules, they find in them a genetic signature that reaches back to life's origins, fragments of an age when the entire world was a furnace. Even our own bodies, so far removed from that setting, still repeat patterns inherited from the first organisms. The way our cells produce energy, process nutrients, and regulate internal heat is a direct reflection of the chemical reactions that once occurred in the primordial oceans. The Krebs cycle, which turns food into energy in every living cell, is a modern version of an ancient geochemical cycle that happened spontaneously in submerged rocks billions of years ago. Life did not invent this process. It copied it from Earth, and in a way, it never abandoned it. Biology still imitates geology, as if the planet continued to live within us. DNA also preserves the memory of great atmospheric changes. Many genes were shaped in response to rising oxygen, ice ages, and variations in solar radiation. Each successful mutation is a mark left by those events. That is why when we decipher the genome of a species, we are reading a cosmic record. The letters that make up DNA are like informational fossils, preserving not only the form of organisms, but also the conditions under which they lived. DNA is the link between what we were and what the planet was. It is the chemical mirror of Earth. Human beings, with all their complexity, still carry in their cells the same molecular structure as ancient bacteria. We are essentially the continuation of the first biological spark that ignited in the seas. Every heartbeat is a memory of the rhythmic pulse of thermal vents. Every breath repeats the oxygen cycle, begun by cyanobacteria, and every cell in the body is a small ocean filled with salts, proteins, and energy, recreating within itself the chemical environment of the primitive Earth. We live upon a planet that carries its memories in the soil and within bodies that carry the planet inside them. When we look at DNA, we are gazing into the oldest mirror in the universe, a reflection of matter's own will to endure. It is the testimony that fire, water, and time never disappeared. They simply learned to organize, to replicate, to tell stories. And the story DNA tells is the oldest of them all. The story of the Earth that learned to remember. Earth is, above all, a rarity. Among billions of stars and planets scattered across the cosmos, it seems to be the only one capable of sustaining something as delicate as life. Its balance is so precise that a slight variation in any of its conditions, distance from the sun, atmospheric composition, axial tilt, the presence of the moon, magnetic field, or amount of water, could have turned this world into just another cosmic desert. But against all odds, everything fit together. The fire calmed to just the right degree, the water remained liquid, the air stabilized, and the temperature found a point of harmony. The planet became an exception, a living anomaly amid the universe's silence. Earth's distance from the sun is the first secret of this balance. Not so close as to boil, not so far as to freeze, we sit in what scientists call the habitable zone. In this narrow ring, sunlight arrives with the perfect intensity to keep the oceans liquid. It's such a small interval that in other star systems, a difference of just a few million kilometers can render a planet sterile. Earth floats exactly in that fragile point, dancing around the sun as if it knew the precise tempo required to sustain life. Every day, every season, and every yearly cycle is the consequence of this precise orbital balance. The moon, the planet's silent companion, is also an essential part of this miracle. Its presence stabilizes Earth's axial tilt, preventing the climate from collapsing. Without it, seasonal variations would be extreme and chaotic, glaciers melting on one side while deserts rose on the other. The moon is Earth's counterweight, the point of balance that keeps the planet upright. Its gravity also drives the tides, moving the oceans and renewing the nutrients that feed marine life. Every wave that reaches the shore is, in truth, a reminder of the invisible bond between two worlds dancing together since the birth of the solar system. Another vital element is the terrestrial magnetic field. Invisible yet indispensable, it wraps the planet like a shield. Generated by the motion of molten iron in the core, this field protects the atmosphere from solar radiation and stellar winds that, without such a barrier, would strip the air and water from the surface. Mars, for example, lost its magnetic field and, with it, lost its breath. Earth, by contrast, kept its metallic heart beating, and thus still breathes. This invisible field is the wall that separates life from the void. Each dawn is a quiet victory of magnetism over the chaos of space. The presence of liquid water is perhaps the most precious trait of this balance. Water is the universal solvent, the medium in which life's chemistry unfolds. It transports nutrients, regulates temperature, and serves as the planet's thermal memory. The cycle of evaporation and rain is Earth's beating heart, responsible for keeping the climate steady. The interplay of ocean, atmosphere, and tectonics creates a self-regulating system in which the planet cools, warms, and balances itself in an endless cycle. Life doesn't merely depend on water, it is largely made of it. Over 70% of Earth's surface is covered by seas, and more than 60% of the human body is composed of water. We are the ocean's continuation, shaped by the same primordial fluid. Another crucial factor is the atmosphere. Thin and fragile, yet perfectly tuned, it retains heat, filters radiation, and distributes solar energy. Oxygen, which once nearly destroyed life, has now become the basis of respiration. Carbon dioxide, once suffocating the planet, has become a vital component of thermal balance. The atmosphere is a living membrane that regulates global respiration, connecting seas, forests, and creatures. It is the planet's invisible lung, and its composition, the result of billions of years of adjustments, is one of the greatest feats of natural engineering in the cosmos. All this shows that life did not arise by chance alone. It endured through an improbable balance between destructive and creative forces. The planet had to nearly die countless times to become what it is. Eruptions, glaciations, impacts, and catastrophes were not detours. They were the instruments that tuned the symphony. Fire made the minerals, cold purified the oceans, destruction opened space for new beginnings. Life is the direct result of this contrast, a dance between chaos and harmony. When we look at the night sky, we see countless stars, yet none of them, as far as we know, harbors anything like Earth. Every mountain, every leaf, every being is the product of a unique conjunction of circumstances. Our planet is the exception that proved it possible. It is the balance between fire and water, between destruction and creation, between time and eternity. And while the universe remains cold and silent, Earth persists here, breathing, remembering, dreaming of the day when chaos learned to live. When we look at the history of Earth, it is impossible not to notice how everything seems to have aligned with almost impossible precision. The exact distance from the sun, the ideal amount of water, the perfect temperature for chemistry to work, the presence of the moon, the magnetic field, the balanced atmosphere, the rhythm of days and nights. Every detail appears meticulously adjusted, as if the universe had calculated the result in advance. And yet science tells us that none of this was planned, that it all happened by chance, shaped by physics, probability, and time. But perhaps chance, when it lasts billions of years, becomes indistinguishable from purpose. Life is the product of a chain of coincidences. If a single asteroid had fallen a bit earlier or later, if Earth's internal heat had been slightly different, or if the sun had shone a little dimmer, nothing we know would exist. And yet, within this apparent chaos, there is a quiet order, a stubborn tendency that always pushes matter toward complexity. Molecules tend to organize, atoms tend to bond, energy tends to distribute itself efficiently. Life, in this context, may not be an accident, but an inevitable consequence of the laws of nature. Perhaps the universe, when the conditions are right, cannot help but create life. In modern laboratories, scientists try to recreate the conditions of early Earth, and what they find is fascinating. Organic molecules form spontaneously. Amino acids appear with ease. Lipids gather into membranes. Chemical sequences begin to replicate. Everything happens without intervention, as if the universe remembered the way. Chemistry, when left alone long enough, seems to know what to do. It is as if the cosmos itself had an instinct for life. In that sense, perhaps the true coincidence is not that life arose, but that it took so long to appear elsewhere. Some say that life is the memory mechanism of the universe, its way of observing itself. Through biology, the cosmos becomes aware. The same carbon that once slept in stars now thinks, feels, observes, and wonders where it came from. Every living cell is a memory of the moment the universe stopped being mere matter and became perception. In this sense, life is inevitable because it is the most efficient way for the cosmos to keep existing. With every generation, matter reorganizes, adapts, remembers. Chance creates pattern, and pattern gives meaning to chance. The line between luck and destiny dissolves. And yet, there remains a mystery no equation can explain. Why does life persist? From the first RNA that learned to copy itself to the first cell that breathed oxygen, life has always resisted, even when the planet seemed doomed. After every catastrophe, it began again. After every destruction, it reinvented itself. The persistence of life is harder to understand than its origin, because even without purpose, it behaves as if it had one. Nature is indifferent, but life seems to desire. That contradiction is what makes it sacred, not in a religious sense, but in an existential one. It is the improbability that refuses to disappear. Perhaps the entire universe is a vast experiment of matter, trying to understand what it can become. And Earth, with its long history of fire, ice, and rebirth, is merely one of the possible outcomes. Maybe there are other worlds where the same process repeats, other boiling seas, other self-replicating molecules, other consciousnesses trying to name the infinite. If so, life is not the exception, it is the rule. And if it is the rule, then the cosmos is, in essence, alive. But if we are truly unique, if this is the only planet where life has managed to flourish, then chance becomes even more astonishing. Because in that case, we are the product of an improbable alignment of chaos, time, and luck, a conscious spark in the eternal dark. And that alone is a miracle without a creator, but not without meaning. Life is the most beautiful paradox in the universe, too improbable to be random, too simple to be divine. It is the meeting point between chance and necessity, between error and perfection. The cosmos did not need a plan to create life, only patience. And Earth was the stage where that patience became form, color, and thought. We are the coincidence that worked, the fire that remembered how to dream. For billions of years, Earth fought against itself. It was fire, it was ice, it was silence, it was collision, storm, and solitude. But somewhere between destruction and balance, the planet found the rhythm that would make it eternal. The heat of its depths stabilized, the oceans settled, the sky cleared. The air became breathable, the seas became fertile, and the light became constant. Earth, which once seemed like a lost inferno adrift in space, was now breathing. It had become a living body, pulsing between the sun and the moon, sustaining the perfect chemistry of existence. After so much chaos, the planet had finally learned how to live. The blue oceans reflected the glow of the newly formed sky, and for the first time, the world had color. The sea had become the planet's heart, pumping energy and nutrients to every corner. The rocks that once burned now held the edges of the continents, and the rains fed the cycle of renewal. The atmosphere, once suffocating, had turned into a protective mantle. The sun, once a threat, had become an ally, and the moon, which had been born from a devastating collision, became the guardian of balance. The universe silently watched Earth's rebirth, the fire that had learned to breathe. Life, small and fragile, multiplied within the seas. The oxygen that had once killed nearly everything now nourished every breath. Microorganisms became invisible architects of the future, releasing gases, shaping the climate, turning rocks into soil, and oceans into ecosystems. Nature had built a perfect machine of self-sustainability. The planet was now a moving cycle. Air fed the water, water shaped the land, and land returned everything to the air. Balance was not static, it was dynamic, like the beating of a heart. Chaos had become harmony, not because it had ended, but because it had learned to coexist. The blue Earth we know today is the final result of that learning. Every human breath, every leaf, every wave, every drop of rain is part of the same system that began more than 4 billion years ago. The atmosphere that surrounds us is made of the same gases once expelled by ancient volcanoes. The rocks beneath our feet were born from the same eruptions that once set the world aflame. Even the water we drink descends from the storms that lasted millennia. We live within the planet's memory, a memory that never stops renewing itself. When the sun touches the horizon and the sky turns golden, the planet relives its first dawn. It is the same light that once reflected off the boiling seas of its birth, the same heat that sparked the chemical reactions of the first RNA. Earth still carries in every cycle of light and shadow the echo of that distant beginning. Everything that came after, plants, animals, humans, is merely a continuation of that breath. Life is the way the planet remembers the fire. And when we look from afar, from beyond the atmosphere, we see a solitary blue dot floating in the dark, fragile, luminous, perfect. A planet that was once destruction and is now shelter. A world that learned to breathe, and with that, to dream. Fire became color, chaos became music, and silence became life. Earth is the miracle the universe wrote with patience. It is the reminder that even when born from fire, life always finds a way to bloom. From the very first instant, the history of Earth has been a sequence of creative catastrophes. Fire, impact, destruction, and silence, all working together, shaping, refining, transforming chaos into structure. The universe never needed order to create life. It only needed persistence. It was the movement between collapse and reconstruction that gave the planet the balance required to flourish. Earth was not born calm. It was born screaming. And that primal scream still echoes in everything that lives. What we call life is, in truth, chaos that learned to dance. The forces that once seemed to be enemies, fire and water, cold and heat, destruction and regeneration, eventually became complementary. Every volcano that destroyed also created fertile soil. Every storm that devastated also cleansed the air. Every extinction made room for something new. Chaos over time revealed its true nature, not despair, but renewal. It is the invisible mechanism that drives the universe toward complexity. Life does not arise in spite of chaos, but because of it. It is the most refined expression of disorder reorganizing itself. The chemistry of life was born from instability, and evolution remains, to this day, a dance between balance and rupture. Without mutations, there would be no diversity. Without extinctions, there would be no rebirth. The entire planet is a machine built from uncertainties that somehow harmonize. Every living being is the result of billions of successful mistakes. Every breath is a reminder that chaos is still here, not as a threat, but as a vital force. Life is the art of surviving imperfection, and when seen from afar, it's hard not to find poetry in this process. The same fire that destroys also warms. The same water that drowns also shapes. The same time that erases also creates memory. The universe, in its apparent indifference, seems to hide a silent intention, to turn chaos into beauty. Perhaps the meaning of life does not lie in perfection, but in the act of continuing to exist even when everything collapses. That is the true intelligence of the cosmos, the ability to persist. Earth is the ultimate symbol of that wisdom. It has been ash, ice, desert, and abyss, and yet it keeps breathing. Every leaf that opens to the sun, every animal that awakens, every drop that evaporates repeats the same cycle of creation and destruction that began billions of years ago. Chaos did not end. It simply learned to become music. Life is the melody that fire and time compose together. When we say the universe is hostile, we forget that we are made of the same material that created it. The iron flowing through our blood came from exploded stars. The calcium in our bones was forged in supernovas. The carbon in our cells was born in the hearts of ancient suns. Cosmic chaos is not outside of us. It is what we are. Life is chaos remembering its own light. The miracle of existence is not that we survived chaos, but that chaos became aware of itself. When we look up at the sky, we are not merely observing the universe. We are seeing matter trying to understand itself. Every living being is a particle of the cosmos contemplating its own origin. Chaos became life, and life became consciousness. Earth, in its blue solitude, is the place where the universe learned to dream. After billions of years of chaos, the planet found balance. Fire turned into seas, vapor became clouds, and time became life. Earth, once a blazing sphere surrounded by storms and darkness, became the only known oasis in the desert of the cosmos. Yet all the beauty that exists here is sustained by an invisible, delicate thread, a small change in temperature, in the composition of the air, or in the amount of sunlight, and this entire balance could unravel. Life, with all its strength, is also extremely fragile. It is the miracle that depends on the harmony of forces it does not fully understand. The history of Earth shows us that nothing is permanent, yet everything is possible. The same nature that created life also destroyed it countless times. Ice ages erased entire ecosystems. Volcanoes buried continents. Asteroids reshaped the destiny of species. And still, life endured. Every extinction was followed by a rebirth. Every catastrophe opened the way for something new. That is perhaps the greatest lesson from the past. Survival does not lie in strength, but in adaptation. The planet is always changing, and life survives when it changes along with it. What we call an end is often the beginning of another way of existing. Today, however, the challenge is different. For the first time, the danger does not come from outside. It comes from us. The same fire that once shaped the planet has returned, now lit by our own hands. We burn what took ages to form, alter the composition of the air, and unbalance the climate. Earth has survived meteors and volcanoes, but it may not survive indifference. The fragility of the miracle lies precisely in our ability to forget it. Amid technology and haste, we forget that everything we are depends on a thin layer of air, a handful of water, and a balance that took billions of years to establish. The origin of life teaches us humility. It reminds us that we came from the same clay, the same fire, and the same water that shaped the mountains. We are not the owners of the planet. We are its continuation. Every breath is a loan. Every step, a silent agreement with the forces that created us. When we alter this balance, we are not merely changing the climate, we are interfering with Earth's own story. Life is too rare to be taken for granted. The universe waited billions of years for something to look at the sky and understand what it sees, and that something is us. If Earth has taught us anything, it is that beauty is born from destruction, but also that every balance has its limit. The same chaos that created can one day demand the price of arrogance. To protect the planet is to protect the miracle of our own existence. It is to recognize that we are part of a cycle far greater than our comprehension. Every tree that grows, every river that flows, every cloud that forms is a direct echo of the moment the planet first breathed. When we preserve Earth, we preserve the memory of the fire that gave us life. The miracle of life is not just that it began, it is that it continues, even after everything. Now that the journey has come to an end, close your eyes for a moment. Imagine the Earth 4 billion years ago, fire still burning on the mountains, vapor rising from the oceans, and the first dawn illuminating a planet that had just learned to breathe. That distant sound, the crackle of rock and the whisper of hot wind, is the sound of life being born. And that same sound still vibrates quietly within you. Every beat of your heart is a memory of the planet's first pulse. Every breath is a continuation of the breath that began in the primordial seas. The Earth was once gray, red, liquid, and incandescent. Today it is blue, alive and conscious. And we, small fragments of carbon and water, are the way it found to tell its own story. When we look up at the sky and ask where we came from, the answer is not in the distant stars. It's beneath our feet, in the ground that carries the memory of everything. We are part of the same cycle, children of the same fire, heirs to the same miracle. So before ending this journey, take a deep breath. Feel the air that comes from time itself, the same air that has passed through oceans, forests, and mountains. The same air once breathed by volcanoes now fills your lungs with calm. This planet still breathes with you. If you enjoyed this journey through the origin of Earth and the story of the fire that became life, leave a like to support the channel. Subscribe to keep traveling through the mysteries of the cosmos, and tell us in the comments, where are you listening from as you hear the sound of the primordial Earth?